Okay, good morning everybody and welcome in the second day of the Atlas meeting. Today's first speaker is Professor David Sánchez of the University of the Balearic Islands. Professor David Sánchez is a physicist with an MA in Spanish, and he has published widely in areas like digital humanities, linguistic stochastic phenomena, and language variation change, including social media corpora. So, David, the floor is yours.
Okay. So, again, thank you very much for the invitation. And today I will present a computational linguistics approach to flamenco. But first of all, let me thank my colleagues, my collaborators in this work, especially Pablo Rosillo, who is our PhD student, and I mean, he did 90% of the work. He's a fan of flamenco. He knows much more than me, okay? And you can find this paper here. So this, let's say, discussion can be included within a, let's say, field called lyrics information processing, which already has quite a few contributions. And we can say that this field is at the, let's say, intersection of NLP, music information retrieval, and computational linguistics, with the goal of analysis, of analyzing textual data from song lyrics. Okay, this can be done in many different ways. Okay, for instance, lexical variation. This is what I'm going to explain today. Okay, but there have been people investigating semantics, the narrative structure of song lyrics, and also, of course, the novelty and influence of certain songs. What kind of tasks can you perform here? Well, the most obvious one is genre classification. Okay, this is what we did here with flamenco, and then one can think of many different applications. Okay, of for instance the genre classification to improve recommendation systems, subtitle, etc. Okay, this is for instance an example. Okay, of a 2017 paper where the author considered, I think, 500,000 songs, song lyrics, okay? And then using a neural network model, he was able to classify automatically songs, okay, according to the genre, okay? This is the confusion matrix, okay? You can see that there is, of course, a confusion between rock and pop music, while here, for instance, hip hop is more, let's say, more unique, okay? And then, as you can imagine, most of the papers in this subfield have considered English lyrics, okay, English songs, and let's say more modern, let's say, musical genres, okay. So I think one of the main research avenues in this field is to consider underrepresented languages, okay, which in terms of music it means all languages except English, basically, and genres, okay, and for these genres there are a lot of minority, let's say, musics which have a lot of information. Because, for instance, in our case, I will try to convince you that to study these flamenco lyrics can open a window into the cultural and history traditions of a lot of people. Okay. So, for those of you who don't know what flamenco is, basically it's an oral musical tradition. Okay, so our work can be, let's say, plays within the context of computational folkloristics, if you wish. Okay, so all these oral traditions of people which have a lot of influence from many different ethnic groups, okay, from Jews, Muslims, especially Gypsies, okay, from the, let's say, 16th, 17th century, okay. And then this finally led to, specifically with a lot of, let's say, identity, folklore from the south of Spain, especially, okay. So, because at that time, during centuries, the south of Spain has been like a melting pot of many different influences, okay, of many different people, and then they came out with this, I think, beautiful music. So, this is a quiz, okay? So I would like to ask you whether you consider this as flamenco or not. Okay? So, this one, what do you think? This is flamenco? No? Okay, good. Let's move on. This one? Flamenco? Sounds like this, okay? How about this one? You know the singer. So this is Rosalía. She's a great flamenco singer. The last one. This is really weird. Okay, so the answer to all these questions is all of these, the objective of this test, let's say, is to show that flamenco has a lot of variations, okay? And this variation can be more or less understood in terms of genres, okay, of this classification. The first one, you were right, this is Sevillanas, which is not considered flamenco, let's say, style, okay? The five, are just examples of different flamenco genres. Okay, the one that Rosalía was singing is this Fandango, which was the name of yesterday's restaurant. Okay, it's an example of Fandango. And the last one is Seguidilla, which is quite slow. Okay, kind of deep lyrics. So how do people classify flamenco songs into these genres? So until now, people employ kind of different criteria, okay? Especially in terms of rhythm, okay? So you heard that there are some genres that are, let's say, faster than others, okay? The tonality, the harmony, okay? The melody, okay? So let's say the set of all musical notes, okay? So basically, these are musical conditions, okay, that people apply, okay, in a more or less subjective way, because I mean you should understand that, I mean there is not any, the author of the song never says if this is Fandango, this is some other genre, okay, it's just the listener who says, okay, this looks like this, okay, so there is always kind of subjective interpretation. So the question we wanted to answer in our work is, what about the lexicon? Okay, what about the lyrics? Is it possible that these genres are also determined or influenced by the lyrics? Okay, so this was the first question. Okay, can we automatically classify flamenco songs only by looking at the lexicons without taking into account the music, okay? And if this answer is positive, then what is the characteristic set of words that, let's say, defines each genre? And the second research question is, now that we know that there are flamenco genres, okay, what is the relationship between them? So can we, let's say, better understand flamenco and also all the music traditions behind flamenco by looking at the connections between the different genres. So we need a corpus, okay? It's, as I said, this is an underrepresented music in, let's say, in computational folkloristics. But then we were able, or my student was able to find this corpus compiled by an English teacher, Norman Clement. Okay, he's a fan of flamenco. He manually transcribed more than 3,000 flamenco lyrics. Okay, and then the information that he was able to get. Okay, was able to label all these songs into one of 78 possible genders. Okay, so there is already some, let's say, limitation here. Okay, first of all, because this is manually transcribed, and second, because the labels are also has some. Okay, they are subject to human annotation, and then you know how this works. Okay, so we let's say try to characterize first the corpus. Okay, so as any big, large text, it satisfies both Ziv law and Heap's law. Okay, well, it's just like a check that this is even if this is, let's say, mainly based on poetry and so on. It follows the typical laws of natural language. Okay, this is the distribution, the genre distribution. Okay, so this is the number of lyrics. Okay, and here in the horizontal axis you can find the different genres. Okay, as I said, there are 70-something genres, and most of them are, let's say, contribute with just a few songs to the total corpus. So, to have some statistical significance, we decided just to look at these 8 most common, or let's say with the largest number of lyrics. Okay, all of them have more than 100 lyrics. Okay, so I will just focus on these, which is, both, all of them are kind of quite well known within the flamenco community. The other are, let's say, less known. Okay. So this is here we plot the normalized density of lyrics as a function of the number of unique words, okay, word types, okay, and then you can already see that there is some difference between the different genres, okay. There are some distributions which appear to be bimodal, like the one corresponding to alegrías. There's one, like for instance, this one, seguidillas, which is more peaked. This one, bulerías, has the broadest vocabulary distribution. Okay, so already from here, there is a hope. Okay, that you can classify a song by just looking at the vocabulary, but just looking at the lexical variation. Okay, this is what the objective. Okay, here we plot the type to token ratio. Well, actually the standardized type to token ratio, which you know is a measure of lexical diversity. Okay, the higher this TTR, let's say the richer is your genre in this case. Okay, so you can see that there that already just by looking at this TTR, you could distinguish between, for instance, these 2 genres, bulerías and tangos, and these 2 malagueñas, seguidillas. But of course, the problem with TTR is that here, for instance, you cannot distinguish between these 2 genres in the top, okay? And also it's kind of global measure, okay? So it cannot give you like, let's say, the probability distribution of the words, okay, within a certain genre, okay? So we decided to do something a little bit more sophisticated, not really, this is not neural networks, or, okay, it's really something simple, multinomial naive Bayes classificator, okay? Well, first of all, we, let's say, perform document preprocessing, well, typical, right? I mean, removing stop words, punctuation, and so on and so forth, okay? We calculate the TF-IDF of all words in all documents. Here, document mean just, let's say, a song, okay? A song lyric, okay? Not, this is just our document. And then just by calculated by computing this TF-IDF, and then, well, this alpha is just a parameter that we can feed to optimize the value of these probabilities. These are the conditional probabilities that, given a class, given a genre, okay, this word pertains to this class, to this genre. Okay, this is quite standard. Okay. Now, we calculate here the accuracy. So maybe it's better if we go to, oh no, okay, I wanted to show you the confusion matrix, which was not here. Okay, so I can I don't know why it's, I mean, this slide disappeared. So we calculated the confusion matrix, okay, between, I mean, what we do is, as I said, very standard, okay? So we take like a training set, okay, and then in the validation set, we, by computing these condition probabilities and the score for each of these genres, then we are able to predict, okay, what are in the validation set, what are the accuracy, okay? And then, as I said, in the confusion matrix, you could already see that this works pretty nice, okay? It works better for some genres than for others, okay? For instance, this, it works quite nice. Accuracy, I mean, here is just the proportion of, let's say, of correct assignments, okay? So for alegrías and seguidillas, this works rather well. For tangos, it works not so well, okay? And then what we did, okay, so now, since the algorithm is able to classify with, okay, more or less a good accuracy the genres, I think it's more interesting to see what the characteristic lexicon is for each of these genres, okay? Now, how do we quantify, okay, in a quantitative way, this characteristic lexicon? Well, since we have these conditional probabilities, okay, which is basically the log likelihood, what we can calculate is the words that have the largest log likelihood. But of course, this depends on the training. Okay, so we do this for a lot of training rounds. Okay, like around 100, and then we plot the words. Okay, or this log likelihood as a function of the word rank. Okay, and then we just focus on the words that always appear or always have, let's say, a non-zero log likelihood, okay? So we arrange all these words by the rank and stop here. So here, so this red point means that these words, let's say from rank 100 more or less, this is for this particular genre, all these words in one or some of this training do not appear as characteristic, okay? Or, in other words, all these previous items always appear as characteristic, okay, in the trainings. So these are the essential words, and then, of course, this depends. These words depend on the particular genre. Okay, for instance, solear. I mean, this genre has a lot of. Around 200 characteristic words or essential words, okay? While other genres like malagueñas have just a few, okay? And then, okay, we can try to interpret these words, okay? We can arrange these words into lexical fields, okay? Here I have an example for two quite distinct musical flamenco genres, okay? So for to the left, we have the words, these essential words that characterize mostly alegrías, okay? This here, okay? So for instance, we have here a, let's say, semantic field which has to do with geography and daily life, okay? Here, for instance, Cádiz, this is a town in the south of Spain, okay? And this is actually the origin of this genre, okay? There is also words from, let's say, the Gypsy community, okay, like Gitano, Primo, Calò. Calò is the Romani language or Romani variety, okay? And so we interpret this since alegrias are, well, just by its name, you can guess that this is a genre associated to parties, to festivities, and so on, okay? So the associated lexicon is consistent with this. On the other hand, we have here seguidillas, okay, which is the last song that I show you, okay? So it's this quite slow, quite, let's say, it has to do with deep feelings like pain, sorrow. This is something that since the Gypsy community was, let's say, discriminated and it was attacked for many years, okay? So they, in their songs, they have this negative, well, negative, or I mean, connected to suffering, okay? And also connected to abstract concepts, okay? So all these, in this particular genre, they have a lot of religious words, okay, like God, and also more abstract words like freedom, etc. Okay. Okay, so I think the answer to this research question is yes. Okay, to a great extent, a simple classifier can distinguish between flamenco genres. Okay, and then we can also, well, in our paper we have all the characteristic words if you are interested. And then finally, we would like to discuss what are the relationships between the different genres. Okay, so here what we did was to calculate the cosine distance, okay, between the different genres. Okay, here all genres are abbreviated with this acronym. Okay, and then, well, you can see that there are connections between the different genres. Okay, well, this can be seen in the dendrogram. Okay, all, for instance, the alegrias, which is already disconnected in the first level. This is telling you that is the genre with the most distinct lexical field, okay? Due to this, as I say, these festivities and so on. And then one way to visualize the connections between all the different genres is by plotting this as a network, okay? And then the weight of each edge has to do with, or is proportional to the cosine distance between the different genres, okay? So you can see that this A genre, these alegrias, is somehow disconnected from the rest, as I said, because they have a distinct lexical items, okay? But it seems that the network is quite dense and connected, okay? So there are strong relationships between these. So since it's not easy to see, let's say, clear relationships, we shifted to a different network representation, which is a minimum spanning tree, okay? Which, well, it somehow shows you the backbone, okay? The underlying structure or the most important structure of the network, okay? And then you can see that there are different branches. As I said, alegrias is disconnected from the rest. Then you have these two, and the origin of these two is that this was this TA genre appeared first, and then TI is like an acceleration of or accelerated version of this genre. Okay, this one is also quite interesting. Okay, because this is seguidillas, this low, deep genre. And Solea, these two are connected, are considered like the most gypsy of all flamenco genres. Okay, that's why we see this connection. And this other connection has a geographical interpretation. Okay, as I told you, this fandango appeared in the south or in Spain, more specifically in Malaga. Okay, that's why this is connected to Malagueñas. Okay, so here we have different reasons. Okay, geographical reasons, ethnical reasons, historical reasons. Okay, and the nexus between all of them is bulerías. Okay, and we understand this because, as I show you in a first slide, bulería has the broadest vocabulary. Okay, so it's kind of you know, like a common genre that has, let's say, a lot of common shared characteristics with the rest. Okay. So to conclude, I think this is just like a proof of concept that this can be done with music genres other than pop music. Okay, so this can be done with, for instance, we hear like flamenco. Okay. Not only by, let's say, performing a genre classification task, but also by looking at the different relationships between the topics, between the genres. Okay, this connection is multiple. Okay, it has many different reasons. Okay, so it's nice to see that just by an automatic analysis of flamenco songs, it is possible for the researcher to look to cultural history, cultural traditions, ethnic traditions, geography, or regional variation. Okay. Of course, our work is not without limitations. Okay. This, of course, depends very much on the corpus. It's not a big corpus. Okay. It's just a few thousand song leadings. So we would like to have more. Okay. And especially we would like to have more because in the future it would be very much interesting to investigate the temporal evolution. Okay, we have records from the 1930s or 1940s. Okay, and here we did not consider this. Okay, we have like a synchronic analysis of all these because we didn't have so much data. Okay, so that's it. Thank you for your attention.
Okay, Anna.
Very interesting, David. I have two questions about the temporal evolution. I was thinking before you show us this conclusion, what do you exactly want to? About the temporal evolution, what do you exactly want to study? The evolution of the lexico. Exactly the evolution of the lexico, and do you think in studying syntactic structures, or because it could be also interesting? And my last question, if you want, but is could it be interesting to test your result doing some kind of clustering, and so it maybe could be easy to get the families, no? The families that you say seguidillas with. What do you think about clustering? And maybe if you get clear clusters, your classification could be not specifically for the styles, but for the families of styles. Maybe the results could be, no, expectedly, could be much better.
Yes. So thank you for the questions. For the first question, yes, the temporal evolution I think is quite interesting. Okay, we applied a backwards approach. So we just, we consider just unigram distributions. Okay, well, in some concepts which are, let's say, strongly linked. Okay, for instance, I don't know, Santa Ana. Okay, so we just put it together and then it's just a unigram. Okay, but we did not consider bigram or higher order because we don't have enough statistics. Okay, we also did not consider part of speech, which could be done, okay, to analyze the syntactic structure. But already in the lexical variation, flamenco aficionados know that the lyrics have changed a lot, especially in.
Okay, our next speaker is Ondřej Tichý of Charles University Prague. He's a lecturer at the Department of Linguistics of the Faculty of Arts, where he specializes in historical corpus linguistics. He serves as head of the Center for Digital Humanities at the Faculty of Arts, with projects that include the Bosworth-Tolo Anglo-Saxon Dictionary Online, the lexicosemantic database of Czech, and the database of medieval Czech textual sources in translation. So, the floor is yours.
Right, now it's on. Yeah. Okay. Thank you very much for your kind invitation. It's always great to be here in Logroño and with all of you. Here today, what I have is not really a research paper. It's more like my musings about a topic that has been troubling me, and I suppose some of us as well, especially in the area of social sciences and humanities. What are we to do with the recent AI evolution in relation to our students, to ourselves, to our research and teaching, and all that. And I'll be focusing on this area, but also on the bridge of digital humanities towards the other disciplines. I've already included the first quotation in my abstract. That's an excerpt from the recommendations. I wouldn't say necessarily regulations, more recommendation of Charles University towards the use of AI for teachers. There's also a text for students, and this bit says that teachers should monitor developments in AI tools and spend some of your time exploring their capabilities, check out what they can do, how they can benefit your work, and how reliable they are or aren't. Actively use these tools where appropriate, encourage students to use AI tools while respecting their varying levels of knowledge and skills, which I think is great. It's a very open kind of approach. But also, it's rather general and not necessarily very helpful to people who don't really know what to do. Similarly, if you look at the text for students, it says, explore, be open, but also follow your instructors, your teacher's instructions. So, but teachers are not necessarily told what the instructions should be. So definitely Charles University wants its teachers to apply, to use AI as much as possible. And I contrasted with two further quotations from recent papers. The first one is from Rüdiger, Blankstein, and Love, which says that 42% of instructors in their survey, it was quite a large survey in fact, and actually 52, so more than half in humanities, completely prohibit students from using generative AI in their classes. While at the same time, another recent paper by Perkins and Rowe says that again in a survey, major academic publishers of scholarly journals do not prohibit the use of Gen AI. Of course, some, but this is, in general. Conversely, many encourage their use to refine and improve manuscripts if their use is declared transparently and so on. So, definitely, if we are preparing students for academic career, this is something that should be encouraged rather than banned. On the other hand, the aims versus the process, they do not necessarily have to align everywhere. It may be useful to ban AI in certain situations, although you in the end want users, students to be able to use them. But this kind of sets the stage, I suppose, between banning and teaching the technology. So when I refer to teaching AI, that can mean a number of things that I will try to look at separately. That also explains my bracketing teaching with AI. So one thing is teaching the theory, teaching how AI works, explaining to students some background of the technology. Another thing, of course, is teaching its application, how to use that. How to use that for the teaching and learning process. That's the teaching with AI, I suppose. And then, its application for research, for the actual work that we are preparing the students for, possibly. So first, how it works. I think we should do that. That's my opinion in general. And I would probably specify the overall aim as trying to achieve some critical AI literacy. And critical can be probably understood in two different ways. Critical in terms of like enough literacy to have some good effect, but also more importantly, critical in the sense that they need to understand it enough to be critical of it, of its outputs, of its products, of its use. And understand it and see its limitations. So another aim can be rephrased as change the understanding or intuitions of how AI actually works versus how computers or internet work. And I think we all, including our students, have some good intuitions about how computers work, how internet works, what we can expect and what we shouldn't expect of them. But from my experience, most of the students do not have this intuition about AI, or rather they kind of think that it works because it's an AI, it's artificial, it's on a computer, so it works like internet and computers, and therefore, for example, it's reliable and things like that, consistent, and so on. And I think this is supported by the survey done by University of Copenhagen last year, although it actually maps the use of AI by students in 22-23. So again, we have to back a little bit to 2 years back, where the ChatGPT, for example, looked very differently, and it didn't have the tool use that it has now. At that time, among other things, 58% students used it to explain definitions and concepts, 34% used it to check if their perceptions are correct, and 28% used it to search for facts and literature. And when you think of the then models without the tool use, these were definitely not the things that they should have been using AI for. This, like fact checking, definitely without the use of search or deep research, not advisable. So I often make the comparison to using Google as a language corpus. That's inadvisable. Of course, if you use Google Ngrams, that's something else. You're using a specific tool that is part of Google for that. So we aim to boost the efficiency of AI used based on understanding some of the concepts that go with the theory. And I suppose this is just, a list of concepts, but I think they need to understand how the prompting works, what is and how system prompt works, what is jailbreaking. Sean was talking about that. I think, speaking about intuitions, on one hand, I don't think that the intuition should be the same as with computers and internet, as I said. So I sometimes tell the students, imagine more like a conversational partner, like another human. But that's also, of course, not accurate. And I think the jailbreaking examples shown that, right? Those jailbreaking attempts would not work on humans, of course. Mostly, I suppose. I'm not referring to, emails asking us to send money somewhere. But I think there are some crucial differences, and understanding, that this is really based on probabilities and text generation on those probabilities shows how these jailbreaks work and why it's not really a human that they're talking to. Things like temperature, perplexity, settings of the models that I think very few users, especially, based on asking students, very few people actually use, but that can be quite powerful. What is an alignment and bias? How does tuning and especially the augmented generation works, the RAG, and other tools, how other tools can be used side by side together with AI. So these are topics that I think they all should have encountered before they start using that in the academic environment. And some of these require some basic knowledge in related areas. So a little bit about probability and statistical modeling, a little bit about machine learning, data mining, neural networks, and for some even technologies like transformers, especially in relation to the following topic, which is kind of aside or separate from the other issues, but I think it really is very useful to have some background understanding of LLMs for disciplines like linguistics, cognitive sciences, and philosophy, because I think it challenges some important questions in those disciplines themselves, right? So, like if, I don't know, one of the kind of very shallow basic aims of generative linguistics is to create a system that generates language. Now we have it. Is that done? Is there no more linguistics in that sense? Probably not. But I think it's important to understand why and to be able to, use those tools not only as tools but as research projects, perhaps. But we need also to do all that without turning social and humanities into another computer science program. So it's very difficult to fit it all in. My suspicion is that, in the future, possibly already in primary and secondary education, students will get some intuitions that they now are getting about computers and internet in general. So they will come slightly prepared for the, to the university system, but we'll still probably need to provide some of that. And probably as part of some of our methodological courses, when we're teaching a little bit of statistics for linguists, we probably need to include this as part of the course, or, citation engines, things like that, tools that are important for them. Now, how to use, teaching how to use AI, how to use it to improve our teaching, learning, and possibly research in social and humanities. So if you look at what different departments and programs have to say about that, based on Galmar 2024, a lot of them generally feel that it's crucial to do that to stay relevant, which is a relatively kind of shallow reason, but understandable. Right, we need to include some AI because otherwise we just seem backwards. And most of them also think that it's important for the job market. Whether that's correct or not, I think we'll see. Probably yes, I suppose. I think that's kind of unclear. And also it seems to be important for research proposals, right? If you don't include that. Like digital humanities in the past, if you didn't include a component of digital humanities in social sciences and humanities, you had less, I suppose, a smaller success rate. And it is, of course, mostly important for digital humanities, and I don't think I need to argue for that. I just want to highlight that this technology is highly empowering for those people coming from social sciences and humanities trying to do digital humanities, because this is really helping to cross the bridge towards computer science, or even more to the developers that are, their necessary part of the digital humanities, of course. Especially in coding, but also in statistical or data analysis. And for learners in general in social sciences and humanities, it can also work as a kind of equalizer in a number of areas. So for non-native speakers, of course, in reception, production, that's really highly relevant. For non-technical students in coding, data analysis, as I said. Also possibly to socially disadvantaged students, giving them better access to some highly expensive things like tutoring or peer and collaborative work that may be difficult to achieve for some students. And for people with dyslexia, hearing impairments, or people generally with disorders that influence language production and perception. And I've seen this quite a lot now. I have students who are very fluent, for example, in talking, in oral presentations, but that have so many problems when they try to formulate texts because, for example, of dyslexia, and it's really difficult for them, and it's also very hard work for the teachers to then go through those papers and, slog through that text. So these have really, if they use the tools correctly, their output has really improved dramatically, and I think it really gave them a lot of confidence that they can actually make it in these fields, in these heavily text text-based, text output fields. So that's great. There is also a survey of certain courses that we are now offering that the Faculty of Arts is offering to their students. We have some that have the aspects of theory in them, so Introduction to DH, Digital Methods and AI in Social Humanities, and of course the courses that do machine learning and that look at AI and cognition. All these have an element of theory, of how it actually works. So based on your angle as a student, you can choose one of those. And then there is also plenty of courses that try to address the application. So AI for the humanities, AI in academic work. These are very similar. But there is also a course AI in teaching. So that's for teacher training purposes, how to apply that, for example, in secondary education. AI in creative process, so that's mostly about the multimodal uses, image generation, so on, how it... So this is a new media, so not necessarily how you should do that to create art, but how it will affect art in the future. How should art cope with that? Our course is specifically aimed at producing research papers around AI or with the use of AI. One topic that crops up every time when you look at papers or talk with people discussing teaching with or through AI, how do you avoid abuse? And what is mostly meant here, on one hand, is avoiding cheating, avoiding illicit use of AI in the teaching process, but also discussion of whether using AI by students is actually empowering, as I said, or if it's actually de-skilling, whether the use is depriving the students of some skills that they should be actually learning. So is it improving critical thinking, right? Critical AI literacy, how should we be critical of AI? Or is it lowering critical thinking because you don't have to think, you just ask the AI? You've probably all seen the paper mentioned Hear Your Brain on ChatGPT, because it really made a large splash in the media. I think all the important news were mentioning that. That's a recent MIT paper. I have some methodological issues with that paper, but setting that aside, I think it's important and it's an interesting piece of work. But it seems that the gist that it's addressing is kind of very intuitive. And that is, if your brain is used less, you use it less, right? That's it. So when they were comparing people writing essays without the help of AI and with the help of AI, yes, the people who were using AI were using their brains less. That's the reason they were doing that, right? They wanted to, not them, because they were in the study, but generally people want less effort. That's why you use tools in general, right? You wouldn't be using them otherwise. So if I approach it from the point of view of teaching, I think what it shows is that we have some tasks that were specifically formulated to be active engagement for the students, to activate their engagement with the topic, essay writing, for example, and turn them into a passive one or more passive one, like reading a book or listening to a lecture, right? When you write your essay using AI, it's more or less like just sitting passively during a lecture. Of course, it depends how you use the AI. And that's the crucial point here. And I think that the point mostly, coming out of this research should be, what are the new ways of engagement? How should we what tasks can we create to engage students when they're using AI to not to turn everything into just passive reception? And there has been, a lot of discussion, and I suppose most of it will just appear with time. But already some examples here. So conversation with AI, using customized models or customized settings to create historical figures, tutors and peers. For example, one survey found that students find it most useful if they use AI as a peer, rather than a tutor to discuss their problems and their trying to figure out problems. Creating interactive exercises that can adjust to student level and needs in real time, right? That's really helpful, because it seems that in the teaching process, one of the key things is having fast feedback and tailored level. So if you can have an exercise that specifically targets your level, and as you're getting better, is getting harder perhaps, and gives you constant feedback, that's absolutely wonderful. And the feedback can be also run from different perspectives. So there has been a teacher who reported on having students write essays, for example, or write ideas, and then have AI react to those from different perspectives, right? So the AI would take, for example, the position of a certain minority, and it would give feedback to the students, to their production, so that they can get, I'm not saying unbiased, but certain, kind of feedback that may be very difficult to otherwise get in a class environment, especially in a class environment that can be, highly selective, non-representative. And there are tools like OneTutor. We are currently running beta of that. OneTutor tries to be like a course-based AI. You put all the course material in there, and it allows students to do things like conversation on the topic based on your course material, but also having interactive exercises based on that course material, things like that. And of course, it can do these things, but it could be potentially used for things like brainstorming tangential ideas and discovering implicit topics in your teaching material, right? So there may be things that you're not directly addressing in lecture slides, but that are kind of implicitly in there, and this can help them discover and discuss them. So going deeper in a way. Again, looking at our own recommendations, concerning, for example, the abuse, one of the points the recommendations make is use of AI should not lead to lower effort. I was just talking about that. Why then use that, right? That's the reason you don't want to work so hard. So I think this can be equated to introduction of other tools into the educational system that lower the effort, of course. But then the reaction usually is that you up your expectations. You expect more complex outputs because the people are now using a tool. So this can be done, especially in DH, I think, relatively easily. You can scale complexity and ambition of projects that you expect your students to deliver with AI, right? Normally, you would start with something very simplistic website. Now you can go much further, without much effort. And there's a report in Rüdiger 2025 that, for example, the teacher allowed AI use in class found, looking at the actual chats that the students were having, that it actually slowed down most of the students, that they were not faster than students who did not use AI, but that they engaged more with the topics. They looked at different positions, and they were practicing more the verification of sources and so on. So it can lead to good results, I think, criticality of the AI output. But in general, I think we will have to pivot from output-based assessment to process-based assessment, looking at how they achieved that rather than what they achieved will be more critical. This I find very handy from Perkins 2024, the Artificial Intelligence Assessment Scale. It shows you at what levels you can allow and how then to apply AI in teaching. From no AI at the lowest level, which is actually at the top here, so you disallow use of AI, can't be used at all, to AI-assisted idea generation and structuring. So you can use AI initially, but then you have to, for example, write the essay yourselves. AI-assisted editing, so you use it mostly for structure, proofreading, things like that. AI task completion, but human evaluation. You may, for example, compare AI, non-AI production, your own, and see, how it compares critically to full AI generation that can also be applied. And it may be difficult to do this, however, in the class environment. How do you disallow use of AI? And I think it really is crucial for the institutions to be able to retain some control, not only for privacy reasons, but for these reasons, in student AI interactions. So for example, Charles University now is setting up its own AI systems. We're, recently one unit of Charles University started the Open Euro LLM development of new European LLM. So maybe in the future we'll go in this direction. Currently, we just set up an open web UI interface on the university-wide infrastructure and country-wide infrastructure, actually, to avoid people, especially students and teachers, using commercial services but going there. And that allows them to access some locally hosted models, the university-hosted models, usually open models, but also access some online models through API. The Open Web UI goes to ChatGPT through API, but there is a central contract that, for example, takes care of, not training on the data sent through that. And crucially, this allows, or should in the future, allow teachers to access and control over the AI and, student interaction. So the teacher could see the whole AI chat of the student. It could disallow, for example, deleting things for the student, so you can really see the whole process. It could allow the teacher to pre-select models. So maybe you only want small, stupid model to work with the, proofreading, things like that. Maybe you want to disallow certain tools. You want to disallow internet search or coding, and you only want, to use that without it, and so on. So I think that will be important, especially for the levels 2 and 3, right, where you want to allow certain part of AI, and however, you will still probably need to do it in class. That's clear. How to do that, for homework, how to work with the fact that students may be using your AI portal, but also other AI portals, that's still kind of unclear. But I think already there, if you say students, okay, use this access to AI, we can see your whole output. If they use another AI during that process, that will become kind of obvious, I think, if you go through that process carefully. All right, I think we're running out of time. This could also alleviate something that is called digital poverty, so different student access to different models based on their social environment, and so on. This is the environment, so it allows you also to set a lot of those settings that people are often forgetting about, so you can also train the theory on that. What does it do when you change p-values and temperature and things like that. It allows you to create custom models, so the teacher can create those historical personas and so on. Research applications, I think I'll have to breeze through this very quickly. But I think that's what most of us actually know, what you can apply it in social sciences and humanities, things like OCR, HTR. Multimodality, I think, is very interesting. So recently I saw our archaeologist, for example, looking at, partially destroyed frescoes and thinking, using image generation and text image generation to actually fill in those areas based on instructions and so on. I'm especially thrilled about annotation and then data analysis and coding. So this is just, a semantic annotation of homonymous words. Bank, is it institution, banking institution, or landscape feature? More recently, we did this when we tried to compare the use of you versus thou in late, middle, and early modern English, where one of the hurdles is that you get about 80,000 results of you from the corpus, and then is it a singular you, is it plural you in reference? ChatGPT 04 Mini-High was very successful in looking at that reference. That's really time consuming because often you have to read the whole letter. It's a letter corpus, sorry. it's a letter corpus, you'd have to read the whole letter to see who is being addressed there. So that has a lot of potential glossing texts like this and so on. And for data analysis, of course, I have already started using that when teaching statistical analysis. Previously, we told students use R. These are the recipes and so on. It didn't lead to much deeper understanding of the code, definitely. And it led to a lot of misuse, I think. Now, when the AI can tell them, like, this is the appropriate test for your data, these are the options, this is the reasons why, this is how you apply the test, and this is its interpretation. We tell them, yeah, do that, but also then take another tool like Jamovi, which is like R, but graphical user interface, do the same test, see that you get the same results. That will, help you understand what's happening. So that's very powerful. And finally, coding. And that, I think, is the most important, mostly empowering feature of AI. So I had great success with students starting the vibe coding, you may have heard, right? Probably inadvisable in general, like for production. But for that dopamine hit of instant success, where you have a task that previously students were these were the blocks that they couldn't overcome unless they took a programming course, unless they had a developer. Suddenly they can do that, very quickly. But then after the vibe coding session, trying to understand how the code works, to tinker with it manually. Like, so you've created a web app. Now, how do you change the color of your background? Go into that, have AI comment it for you, try to do that. That, I think, is a good path for learning. And now all the hurdles, including the custom code, but also including deployment, have been mostly removed, so it's really instantaneous. But probably after that, what should follow is, using agentic coding and moving from the role of learning to code, to be a proper coder, to learn to be some kind of orchestrator, right? A team leader, where you have agentic AIs and you just need to orchestrate them, and that's really difficult. There are some points that I think should lead to more responsible use of AI for coding. Can have a look at those. But yeah, I'm out of time, and I just wanted to show you some of those one-shot things, like creating a little game, or we did that recently, right, with Mark in our common project. We taught the students data mining, so we web scraped Early English Law's website, which is a website that famously, a digital project that famously went down, then was restored by University of St. Andrews. So in one session, we scraped the data and then asked AI, do the site for us from this data. And arguably, it one-shotted a better site than the current one, which is nothing against the effort by St. Andrews. It's wonderful that they were able to restore that for all of us. But yeah, it's pretty neat that you can do it now. And with that, I'll finish. Sorry, I took more time than I wanted to. We can go back in questions to this, for example. Anna.
Okay, thank you. We have a couple of minutes for questions. Just 1 second.
Only to say thank you very much for your insightful presentation. And do you have written your ideas, your presentation in some publication? Because I would like to go through and take ideas and prove it and so on.
Thanks for that. I haven't really thought of that as a research paper or something to write up. I thought of that as as just a review of my thoughts and some literature. So I can, of course, send you the presentation. I mean, it will be probably available. But maybe, yeah, it could be possibly. I don't know the type of journals that would do this, but because that's not what I usually do. Maybe. I can probably pair with some of our educators and do that.
Thank you.
Thanks for that.
Thank you for the interesting talk. And I mean, this is interesting research, especially in education for our students and for us as tutors. My question stems around how do you ensure? I mean, this is very and Doa's work, which they mentioned yesterday about, detecting AI-generated text as well. I know we've tried in MMU, we've tried to build into the process as well, where students will actively tell them, this is the task, go and use a specific, it was actually Copilot, so use Copilot and try and improve and give an evidence of what Copilot has produced and try and improve on what Copilot has. We will grade them based on how their own work is better than that of Copilot. We also want to see the prompts that they have created to try and improve. It was actually a data science problem. So has that been taught about as well, in terms of actively looking at how the students have created this solution and also how they have used AI? Well, of course, we're encouraging them to use AI, but is there a metric that you think we can apply to gauge whether they are better than the AI themselves?
As a way of assessment, like
yes,
how
as a way of assessment.
Well, I think that's very similar to any, critical type of assessment, like, writing a reaction or criticism of a previous paper. I don't see a straightforward way to assess that, but I think of course, if it's their own AI production, that is, they elicited the result that they're criticizing, that's more difficult to deal with because you will have very different products for all the students. But maybe if you prompt the AI, then give them the product and say, criticize this, so it's easier to compare in between the students. And also then telling them, use that criticism to produce a better prompt. Try to get it right, one shot good. That could be also assessed, like how successfully they were able to do that. And that, of course, is a different discipline. It's no longer, essay writing, but that's a prompting kind of exercise. But that can be also very useful, I suppose. But I don't think I have any specific answer on how to assess.
Thank you.
Hello. We also have an online question. They say, what's your opinion on the move back towards pen and paper that some universities are implementing?
Right. I mean, I understand why that's happening. I think we should try to do as much to avoid the necessity of that. I can see that in some cases, yeah, that's probably necessary. I think it can be fruitfully combined with this. So I can imagine, for example, allowing the students in class to use AI, especially if you have, like dedicated AI channel like this. So get ready for a topic, get ready for essay writing, just take notes on a piece of paper, and then we'll remove the computers and you will produce a text. Or, again, control environment that doesn't have to be necessarily pen and paper, that could be laptops that are restricted in some ways. Or another, I suppose, possibility to avoid that is the processual kind of assessment. So we don't really care what the final essay looks like, or not. That's not the crucial part, but how have you come to that? What was the process? What you used, and so on. So, and I think partially we already do that, right? If I have a dyslexic student who's really struggling with formulating text, even today as a supervisor, for example, I put much more effort into that, and I help formulating the text way more than I would to other students. So in a way, the final output is not comparable. But I can see that that student has, as brilliant ideas, is putting as much, if not more, effort into that. And I can assess based on that, rather than just on the final product, which may have been partly my work in the end. So I suppose, yeah. But I think a lot will just transpire. And I think we also need some time for the technology to settle a bit, because the situation is so different than 2 years ago, thanks to the tool use and the agentic possibilities, right? I think the recommendation, if you look at the recommendations from 2 years ago, you can already see the holes in there punched with the models that appeared this year.
It reminds me of when calculators came along, and there was a whole panic in schools. It reminds me of when calculators came along, and there was a whole panic in schools about the use of calculators. Maths hasn't died,
Yeah.
as a result of that. But I suspect this is a similar thing.
Yeah, I think that this is a comparison often made, and I think there's a lot of truth about that. But also, I think that this is a more transformative technology, so we shouldn't just completely disregard it. But I agree that, yes, we've always known that the brightest mathematicians may not have been the best in calculating from the top of their head, and we, I think, know that our best thinkers are not necessarily the people who write the most fluent text. That's, however, maybe the relation between formulation of thought and actually thinking is narrower, closer than calculating and mathematical thinking. But I think this is such a wonderful field of discovery in cognitive sciences. Like, how does this actually relate? Is it really necessary? I think maybe in a couple of years we'll just be thinking, like with the advent of printing, why were those people really drawing the individual letters? Like, why were people writing in full sentences and paragraphs when I can just do bullet points and then, I can have a tool to produce a... Maybe, or maybe not. Maybe we'll just all go stupid.
Maybe the danger of using AI for writing could be that a human being begin to write as machines, I mean, with the same style, with the same ideolect. And it could be because they, as we know, they write in a very plain style. So the danger is to lose our freshness, our personality.
We can definitely see the convergence from both sides, right? The development of the models, and I think especially we can appreciate it with the talking models, how much they achieve even like disfluencies to sound more natural. The advanced speaking mode in ChatGPT, for example, and other tools, how much of disfluencies they have been able to introduce to really sound human. So I think the models will get better in this to sound more human, but also, and I wanted to mention that yesterday, our colleague has just started a year ago a grant that looks at how people start writing more and more like AI, and that he's already shown that that's happening. So convergence. On the other hand, like language standardization, that's been it for hundreds of years, right? We have been kind of pressured into a relatively narrow linguistic area when we want to do things like publishing.
It would be a pity because we look in that case we will lose our personality, our identity.
Or a next step of linguistic standardization. I don't know. Well, but I think the main point, looking at the standardization process as a whole, is that we don't necessarily lose all of that. We'll just stop using that for certain, for publication. We'll have maybe even straitjacket. But for, private communication, maybe nothing will happen. I don't know.
We'll see.
We'll see.
Okay, let's carry on with our next talk by Dr. Kulvinder Panesar of the University of Bradford. She's an assistant professor in applied AI, and she has also been a senior computing professional in natural language processing with a focus on AI for good and healthcare context. So she has co-authored many NLP and cognitive linguistic papers, and she's a current co-investigator of a British Council grant. So thank you for coming, and the floor is yours.
Okay, so thank you, Francisco and Anna and everyone for welcoming me. I really appreciate that. That's absolutely warming. So topic is a semantic graph motivated and ethics by design strategy for AI solution development. It's a case study approach. So my approach, I'm gonna basically cover a few concepts first of all. I'm gonna cover a little bit of my background to give you a context for my main part of my talk. It's going to be knowledge graphs. That's what I'm focusing on. And then what I'm also going to do is look at, obviously, responsible AI. It's highly necessary. So I'm going to introduce how how I've introduced it in the actual case study, and then I'm going to come up with a couple of key takeaways. So that's my approach. Okay, so I'm just going to philosophize a little bit for 30 seconds. We can only see a short distance ahead, but we can see plenty there that needs to be done. Now, we all get this. Now, with this conference in mind and the particular course that I sort of felt that I needed to gear towards was a master's degree in language processing and applications of AI to linguistics. So what I see is this happening, cross-disciplinary, interdisciplinary, multidisciplinary. So the idea that you've got all these different skill sets, what you're trying to do is you're looking at this deep integration of these different disciplines to create new knowledge. At the same time, what you want to be able to do is see one discipline through the lens of another discipline. So this is the way that I'm sort of approaching this. Okay, so the AI ecosystem, we're all familiar with this now, and a lot is happening. I don't even need to show you, I mean, obviously linguistics, obviously we've got the NLP side, the multimodality, and we've obviously got the AI agents. I actually do show a couple of those examples later. Okay, I'm going to go straight into the knowledge market space now. From a linguistics perspective, we have ontologies. Knowledge graphs should not be, are not sort of new at all. In the knowledge graph space, there's actually, graphing comes in different forms. Graph analytics, complex questions, like it says. Graph AI, this is where we're using our machine learning approaches. And as we can see there, more than 20% of the research published is in the top AI, is related to graph related. And then you've got your graph databases, and my focus here is semantic graphs, and particularly our area. So investment-wise, what do we have? We've got so in 2024, we've got 1.1 billion, just over 1 billion, and then it's expected to be 6 times by 2030 in the knowledge graph space. And if you look at the technology landscape, it's absolutely growing. So this graph processing engines is something I'm going to look at. We've got the graph databases, NLP, as you can see, there's quite a spectrum there. Now, so my focus here is going to be looking at one particular graph engine, which is Neo4j. And Neo4j has got loads of properties of, compared to normal SQL, no SQL. It's developer focused. We can create queries very similar to the way that we would want to query a database table. And it's got all that orchestration side of things as well. And some of us don't know, but Neo4j and knowledge graphs are behind the scenes of all our social network. Your likes of Facebook, LinkedIn, they've all got knowledge graphs which are sitting behind there, absolutely complex to the N. Yeah, and as the example stands, fraud detection, etc. These knowledge graphs have been used. So Cypher, this is what I'm going to show you in the example later on. It's a declarative language. We can clearly, state what we want, familiarity, and it's based upon graph algorithms. So that's just. So let's just go on to the actual knowledge graph. So just as an example there, everybody knows about ontologies, structural framework. This is what linguistics is based upon. And when we want to introduce a semantic layer, we actually want to be able to understand the meaning, the relationships between the meanings as well. Now, so if I just go into this top graph, there's a little bit of, there's 2 ways of looking at the graphing space. There's one which we call the resource description framework, the RDFs, and that's very, very useful when it comes to your resources and your from a web perspective. But I'm interested in the second one, which is the labeled property graph, where we have nodes which I've got based upon are recognized as properties with key value pairs, and then we've got nodes which are connecting via relationships, and then we have again, that's that basic structure there. So just a little bit of information. There's nodes, there's edges, which are called relationships, and we're trying to define semantics, enforce meaning between the words. And any sort of knowledge graph, it's a tree structure, so it's got an algorithmic sort of statement there with the nodes and the properties there. And I come back to this in another later example. So here we've got this hierarchy, animals. Animal is a living animal. And then you've got plants, which is also a living animal, just as an example. And then you've got the example of Bob is interested in the Mona Lisa painting, etc., etc. And which is by Leonardo. I can't see that from here. And then what I've done is I've shown you an extended one where we introduce more nodes, more relationships. We could actually get more meaning out of that as well. And what it is that we need, we can have links, but we've also got, we can have links and relations, but we need the meaning between them as well. So for instance here, from a large language model perspective, here I've got an example. The user owns a gold retriever that has a disease. We need our LLMs to understand that, obviously to reduce hallucinations, to reduce fault injections, and a range of other, and also being able to work out any causal relationships as well. So just as an example, what a knowledge graph can do for large language models. Now, one of the things that I need to also show you is external space. I mean, yeah, there's investment, but what does Gartner say? This is the world leading research development institute on everything technology, and Gartner sees knowledge graphs as basically a critical enabler, and it's almost like it's got a renaissance. It's come back. It's an impactful technology, and as it says, has merged for enterprise-wide success. And then on the other end, this is something that I'm going to talk about in terms of my own research. Gartner's also saying that we've got data-driven AI, which is all our machine learning, large language models, etc. But we've also got the symbolic side, which is where we're going to start looking at meaning. And this is where our linguistic side really comes into play. And this composite AI is the way forward in terms of building solutions. And then just as the hype cycle goes, it shows that knowledge graphs is what we call on the slope of entitlement. And that's because we've seen a lot of success with it as well. Okay, so just to give you examples. So when it comes to the AI space, what we've got our, if I look at the bottom here, this particular one, which is the arrow for the laser? Is it the one with the red star? Yeah, it is. So when I look here, so this example here, this is what all of us have already been doing. Yeah, and then when we introduce a little bit of extra knowledge, we introduce data sources, and we're basically expanding and getting context to our actual results. And then we've got the agent space, which is all happening now, where we've got memory planning, we've got tools, we've got the orchestration itself, and then we've got decision making. I don't want to look at the concepts, but then if I look at so the bit of introducing the extra resources, which is what we've got here, is when we can introduce all these extra resources. We can, and all that content's going to be embedded using various embedded methods. I won't go into the technicalities. But then coming back to the knowledge graphs, the graph RAG, this is sort of like the area that I'm sort of focusing on here, so that I've got my knowledge, and what I'm doing is I'm embedding using a graph processing engine. Is everybody okay with that? Yeah? Okay, so I'm going to just move on. So why knowledge graphs? Free schemas, embedding as key value pairs, a whole host of, reduces redundancy, a whole host of, just check my time. Okay, so onto the knowledge graphs then. This is really, I'm just to show you here that, and I'm actually going to show you a demo of this. So you create your nodes, you create your relationships. What you do is then you try and do a match statement to say what is the connection between one node and the other in order to establish a relationship. So here you can create some here's some statements here, and you're creating constraints on them as you would do any sort of entity, the fact that it's got a particular property constraint as well. So, and then there's a line of code there that I've included. So who's been using this for a while? I don't really want to go through the example. It's Google. So anybody attending a conference, they will do some deep analysis of what they attended and really what industry they're from in order to gauge, what their potential audience may be for future conferences. So just as an example, and as you can see, it's using Neo4j. Another bigger one is LinkedIn. The LinkedIn engineers have been working on their customer ticketing system, and what they've done, again, they've used knowledge graphs for in order to a tree structure, as it says, generates beddings for each node, and then the Q&A phase, and that's how they're being able to get those subtle meanings and the responses that are required for their for the actual response tickets as well. Another big one, because healthcare is something that I've worked on. This is not my work, but again, here you've got specialized, personalized knowledge graphs created in order to be able to build specific outcomes for individuals and for holistic outcomes in order to find relationships between medical concepts, concept-specific knowledge graphs, and obviously you've got your personalized ones as well. So there's a lot of work and infrastructure, but as you see, it follows a pipeline. Okay, so what I'm going to do is I'm just going to highlight. I started on my own, as everybody does. So I was doing in 2020, I was doing all the conversational AI versus statistical versus linguistic. So I was one of those people who said, well, here comes machine learning, deep learning, but here we've got the linguistic approach. That's what I started doing. And then I joined forces with Dr. Maria Perez from UNED, and we basically had 5 years of work. And she was interested in semantic memory and amongst other things. I'm, as a computer scientist, also interested in cognitive decline, as an interest, having had some personal experience of dealing with people with dementia. And then through that, created frameworks, and I'll show you those examples. So we did all sorts of, papers, designs, architecture, keynotes, all about this, where when multimodality came in, I introduced multimodality as part of a cognitive decline assessment that we have called the mini state mental assessment, MMSE, state examination. So where they have questions that they ask when you go for a cognitive assessment, followed by a drawing task. So that's how we introduce NLP and computer vision as a multimodality sort of solution. And there you go. And then the latest one was the last one is how do people live independently? So I'm just going to show you some examples of where I started my knowledge graph journey. This is way back 21, where I was embedding it in as part of a bigger project, and it was more for the assessment part. From the assessment, let's just leave it there. And again, like I said, it's from the assessment. And then what I found was that I had a whole framework that I needed to work for. Before I actually could work with the knowledge graphs, I needed to get my content, needed to get my results from the actual assessment first. And then we've got the global deterioration scale as well. Somebody was talking about defluencies earlier on. So obviously I need to talk about speech defluencies. People who've got cognitive decline are not going to be speaking eloquently, and I had a framework to embed that in my in both the actual initial assessment and the post analysis as well. And then, bringing in linguistics, I brought something in from Role and Reference Grammar. Carlos, you're familiar with this, psycholinguistic cognitive adequacy. So there was a lot of linguistic elements brought in, as well as computational. So the fact that we were mapping what a conversation means with the actual levels of language as well. And what we did, this is just an example. I took 2 sentences. You can see how I've been able to, based upon the sentence, there's a full assessment of 22 parameters that were used. There was for language production and language cognition, where where some of these were some of the results, and some of these results were done blind. So Maria and I would assess separately, and then we would come to an agreement as to where would we paste that, and this is the language cognition side. So I've just cut long story short. Once we got the assessment, you can see that now I'm getting my data points. I'm putting things together. So I had 40 to 60 utterances. So strand 2, that many utterances, 100 to 150 utterances, 10 participants, and then obviously creating the ontology, cleaning, importing, creating nodes, and creating the relationships type. So as you can see, I started building the framework, and then the next stage was obviously taking it into Neo4j as my graph processing technique. So I'm not going to show you that because that's not so important. And then my last project was about independent living. Again, knowledge graphs was going to be key to how individuals were going to be provided responses. When they asked a question, those responses were going to be based upon knowledge graphs as well. So this is the work that I started last year, and it's an EPRSE proposal which I didn't submit, but there was a lot of work done. So the other big thing, which is what we're coming on to now, so I've been working with a joint student and university on commercial projects since 2021, and this is the last year of it, and I have the full journey from idea, concept to development to deployment, and that's the stage we are in. Literally the next week we are finishing the project. So what I want to do is I want to take you through how I've used knowledge graphs for that, and how I've used ethics as well. So the project is called Patient Bot, AI-driven pharmacy OSCE simulation software as a service. And the idea is that we have an AI bot that acts as a patient and it acts as an examiner at the same time. Okay, and the idea is that we're assessing their clinical skills, their diagnostic skills, and their rapport in terms of how as part of that consultation as well. So these are the two things that I'm going to follow up with now. I've also been an ethics advisor, so there's a product that I've actually been part of with a company, and we were given full access to this with this product. Doing because of my connections, whereas it was a big sum that they would have to pay. Okay, this is OSCE. I think I'll probably mention this to you. Software as a service, semantic knowledge graph, and ethics by design alignment. Those are the two things that I'm particularly showing you today, which are very geared towards what is necessary, obviously, from a linguistic sort of language framework. So, yeah. And obviously a lot of cost savings, because if the idea is that this particular bot, the university will use it, it will be commercially available for other universities. Over 10,000 students do these OSCE exams, and the lecturers, the tutors have to be available during those consultations. There'll be a lot of savings, so there's a massive, this would be massive impact. So we're trialing now, so that's the stage we are at. So this is a video, and I'm hoping it will play. Oh, is it playing already? Oh, okay. All right, it is playing already. So yeah, so basically all I want to say is that I've used KNIME for my design infrastructure. Neo4j is the actual graph. This is KNIME. Basically, this is only a snapshot. This is not the real deal because it's IP rights. I had to create something just for this demo. So what we have is you start off with a node. We want to work out the condition of patient 8 at 10, and then when you look at condition a patient with condition 10, you find out that as you go through the match, on the patients, and then you work through it, you find that there's 8 cases of those patients with that similar condition. But then when you look at a particular patient, you find that they've got multiple conditions as well, and it goes on. And all of this we can actually query, but then we can also represent as a graph database that we use as part of the consultation stage as well. So, yeah, it takes us through at various points where you're creating certain matches, yeah, and it gives you a visual of all the nodes and the labels that it's using in terms of that query. Sorry, I can't physically see from here, so I am going to, and then you've got the actual visual code. So this is the environment where we're running the .NET environment, and then we've actually got the results that we can also see. So we've got the visual, we've got the results at the same time. I think I'm going to move on. Okay, all right, so knowledge graphs is a massive part, and like I said, I've only just given you a snapshot because, for IP reasons, I cannot disclose that. Let's move on to the ethical part. Now, from an ethical part, everybody knows about responsible AI practices. We've got risks, we've got ethical design, we've got data governance, we've got obviously the side of, AI literacy, risk, being readiness as well. And there's all these aspects of explainability, transparency, and all of these common terms that everybody knows about ethics. Now, again, there's so many different angles to look at this. We've got, you've got at the above, you've got CAP AI, which is one of the earlier tools, which was a perceived of conducting, it's a conformity assessment, and that's all it did against the EU Act. You've got, the Alan Turing with its safety in practice, and it covers safety objectives, key tasks, best practice, life cycle integration, and safety principles. And then you've got the AI Act, which is more risk-based, and that's the approach that I followed here. Now, one of the things is this particular product that I worked with this company, we've now getting to the point where it's associated, it's been, startups can use it as part, as soon as they have the idea, they can use it. So that's where it is now. So I obviously used it a few months ago. So I was the first person to give them this was a guinea pig project for them, and now that they're introducing this product for students, for staff, from management, and it's become a full university sort of program as well. Likewise, the patient bot one in its own realm is going to be for universities. So this product is one of a kind in the sense that I was part of building it, in the sense of covering all the standards. So it looked at EU Act, it looked at the standards, it looked at UNESCO, it looked at NIST, it looked at safety, it looked at risk, it looked at the health and safety, GDPR, it looked at everything. And what we did, we had an 8-man team, and we were worldwide, and each of us took a separate area, and we focused on that separate. So I looked after NISC, and somebody else looked after UNESCO, and we put this project together, and it went through about 25 revisions. Yeah, as we built, as we tested, and obviously it's a front-end interface. So what it covers is, from all of that, it covers 5 areas of rights and privacy, purpose realization. Is your purpose really, is the purpose right, what you are using AI for? Sustainability management, risk evaluation, and accountable redesign. And the idea is that using a tool like this, where you do ethics by design really early, you're making savings, you're speeding, and you're actually owning what you are working on your rights and what you can protect, rather than passing it on to third party sources as well. So yeah, the risk-based approach was considered. So we felt that it sat in the limited risk side, however, with bringing lots of things into play. So one of the things that this product does, it also covers something called the ISO 24001 standard, and it's the AI management standard. So if you are building a system, you also need this in any system. When we build, we have process standards and we have product standards. So we know what we want to produce. How we're going to do it is also a standard. So this is associated with that. So so all of this is embedded in the tool as well. It covers, all the industries, ethical considerations, risks, and obviously helps with you being able to ensure you've got traceability measures, explainability measures embedded in. So this is how it starts off. I'm going to give you a snapshot of what's in the tool. So when we go in, we can choose. So so this is the name of the company, and this is, you choose what acts you want to follow. And if you select them all, then you get a bigger question base. If you select shorter ones, you get a smaller test base. And that was the idea. So you've got your sustainability goals are also introduced. You've got the ISO standard there to GDPR. So this is like one run. We went back and did another run. So I've just given you the very first run. And then when you go in, you get a dashboard. At the moment, nothing's happened. You've got scores, you've got risks, you've got actions. There's actual textual based actions, which I included. And maturity, which is actually showing how you are doing from several assessments. And here's a question, first question, and you can imagine there'll be about 75 very detailed questions, which may be a paragraph long with options, with some explanations. Does the product complete a task normally carried out by humans? So you choose your option, what the compliance it links with, what the linked compliance is, and what reference does it have from a sustainability perspective as well. And then what you could do as part of writing it, you can actually put in actions for yourself. Yeah, to say, I need to do this. I never thought about this. This is a tricky question. So that's just an example. And over time, you get your result. 5.08, and then you get the maturity, and that's after 3 assessments, as you can see. And somewhere along the line, the latest assessment, previous assessment, and there's something that must have happened in terms of the product. Yeah, there's not a progression. It's gone from down to up to down again. So. And then you get scores, and then you get the scores for the individual principles as well. So here we can see that, for instance, seamless management, there's no score for that. So that's an issue. That's something that's cropped up. You've not thought about how will you enable seamless management. This is about continuous integration, continuous development. What measures have you got for that? So this is giving you questions straight away. And then what you do is you get your assessment, and then, so I'm an AI, I'm an expert reviewer. So if a company did this, I would receive the assessment, I would be that stage, and then I would review everything, and then I will give them another review. So there's a review they do themselves, then the review is done by an expert, and that's the idea. And then so from this, what we found was my team, the group that I was working with, they're both students, one's a pharmacy, one's an ex-GP. Both of them did not understand, obviously, the whole software development, the AI system development cycles, didn't understand how programming works, and what I got them to realize was we need all these strategies. We need data strategies, AI strategies, migration, deployment strategies, privacy, backup. We need everything. We need to know about how the LLMs are going to be managed. It opened up loads of, and what we did was we also they didn't realize about the impact of LLMs. So the introduction of, so Sean was talking about jailbreaks. So this is the only way I could get them to understand was this tool. So we introduced what we call guardrails at various programming levels, rules and heuristic systems, regular expressions, pattern matching, which were done already in some cases, and fine-tuning the models, topic detection, toxicity, all of these things, and various levels of guardrails, which I think I put on. This is a paper that I thought was really interesting for you to, the return on investment of AI ethics. It's from the Digital Economist. I would suggest reading this paper. It's really good for anybody who wants to see the actual areas. Sorry, there's a typo there. What we did as part of our product was, because of the semantic RAG, we use large language models as a judge as well. So we use a rules-based process of assessment. We use large language model as another assessment means of the consultation, but then we also used it as a judge in a third way for validation. And and then also this bit about readiness as well, which is something that they learned. So this was empowering them, and this is somewhat my last slide. So my key takeaways from this now is that we're moving forward so fast. Now we've got we had the multimodality, large language models. Now we get the multimodality graph language models, where now we can see it from different perspectives and we can bring them together. What we have, this thing about, so a famous quote that I found on LinkedIn: "You won't lose your job to a tractor, but to a horse who learns how to drive a tractor." Yeah, so this is how things are happening. Everything is taking a different form. And then now, as we were talking about, now we've got agentic AI, where it's going to have planning, it's going to have memory, it's going to make decisions for you. And we've got all these tools, and the orchestration is put together in order to give you these goals that you want to achieve. And then at the same time, we've got to, knowledge graphs are going to be key part of it, as you can see there, as part of helping with what we call the invisible AI product, which is where the composite AI side is. So so the agentic graph, this is like a book which has just come out last week, so this is where it's moving. So we had the agentic AI, now we're moving on to the agentic AI RAG, which includes using knowledge graphs as well. And the big thing now is that we had the prompt engineering, and Ondřej mentioned this earlier on about the context entry. The bubble has gone bigger. So we had the prompt engineering, we've got the RAG, now we've got the context engineering, where we've got to look at obviously the state, the history, our memory, and all the outputs and related process data that we have. And it says, like it says, 40% of agentic are in danger, because if they are not thinking about the context through and through, because even with knowledge graphs we are doing that, but holistically thinking about context. And then here now, what's happening is that we've got a whole set of protocols which are coming out where, content engineering, knowledge graphs, we need to learn how these new ways of communication, as part of that orchestrating it, there are new techniques which are coming up in order to make orchestration easier. So this space is changing a lot. So the whole idea, I think I have got a last slide. Oh, I didn't. So one thing I just wanted to mention, the jobs, from a job perspective, there'll be a lot of what we call AI advisors, AI ethic, fairness analysts as well, that will come out, and they are going to be what we call AI context engineers coming out, AI knowledge graph engineers as well. So there's a whole space which is changing. So I think I'm going to stop there. So thank you.
Okay, thank you.
Okay, and I've got a last slide with some questions, but if there's any, any questions?
Very quickly.
No questions whatsoever? Yeah. Ondřej.
I think I can just very quickly ask the two that you've shown, one to help people who live with dementia, I think.
Yeah.
Is that already
No,
available?
so this is the work that excuse me. So this was this one. So this is a full EPRSE NIHR full proposal with good 9 months of work, and the idea was that this particular product, Matti, you would be able to have support with your food and drink, your safety around the house. There was a lot of sensors. You had wearable sensors. You had sensors around the house. There was knowledge based upon a person's individual house setting, the rooms, where the toilet was, the distance, videos of everything. So all of that was part of the actual knowledge, and there was other knowledge-based data that was introduced. Now, unfortunately, I did not submit this, but I spent weeks. I had an occupational therapist on board, a speech and language. I did the whole shooting match. Yeah, I didn't submit it because I think I got to a point where, peer reviews were done. One was great. One was like, you need a week or so more to just tidy this up. And it was over the summer period where everybody goes on leave and you're putting this capability, you've got a team which are very, very capable, but nobody is giving you their right annual leave times. So I've realized that, the lesson learned was that, if you have a capable team, make sure that they're a capable, consistent team as well. Yeah, and so I didn't submit this at all. So this is grounded from my 4 or 5 years of work. So all I now can do is to say, well, let me take this and transfer this into real life projects. Yeah, and all the the orchestration parts, again, I can take that. So as the technical lead for this project, we got an award. Not for this one, for the actual AI patient bot one, we got a reader award, and from that I hired an NLP developer. So literally I gave him all my research work, all my ideas, and to say, well, this is what I want to build, let's orchestrate this together. So we have been literally together designing, building this for the last year. And we've come to the point where, we've made it scalable. So I think everybody's, research takes you in different directions. There's a lot of transferable knowledge from here that can be used in all projects. So that's the way I've seen. Very disappointed. It was heartbreaking, really, tears, everything I had. But sometimes you have to call it a day on certain things. And I know that there's a lot of work done by the dementia studies. So we have a full center for dementia studies at the university. And I probably wasn't there at the right time when they started their project. So it's hard to join projects and bring a big, heavy technology, landing to them, to say, well, this is how I can help you, whereas they will work with technology what suits them. So I think sometimes it's a clash of different departments and where you fit in. So I think I know where I can use it, if you know what I mean. But I know it's absolutely valuable. And I actually had a client who came with this same problem, who wanted to build this. So that's still in the pipeline.
It seems highly relevant.
Yeah. Thank you.
So we continue with the last session of the Atlas meeting. Our next speaker today is Professor Mark Faulkner, who is considered our expert in both the transition from Old English to Middle English and computational approaches to medieval English. His new literary history of the long 12th century, news and academic changing according to reviewers, was published in 2022, winning the ISEME First Book Award. He has simultaneously been pioneering the application of big data technologies to medieval text to allow contextualization of the script and language of text within the entirety of surviving medieval writing, using data sets enormous by comparison with the norms of the discipline. While his background is in English literature, as a philologist, he has also published and taught extensively in book history and linguistics, and indeed across the whole sweep of medieval studies, devising and directing one of the leading master's programs in Europe in this field, which is the Master in Philology in Medieval Studies at Trinity College, Dublin, and founding the Trinity Centre of the Book, one of the major centres for book history in Europe. So his talk today is entitled Corpus, Palaeography, Machine Learning, Scribal Profiling, and the Dating and Localization of Manuscripts containing Old English, dating from date to the 1200s.
Thank you, Anna, and well, thank you for the invitation, and thank you to everyone for being here and for listening. And I should say that this is really collaborative work. I'm presenting. Most of it derives from work done with Elisabetta Magnanti, originally of Vienna and now in Trinity. And she's the computer scientist, so she's probably actually the better person to be here, but you've got me, and I'll do my best. As Anna said, I've been working on sort of scale for maybe 10 years now. And it always struck me in traditional philological textbooks that the data is very small. So here's not an atypical example where a particular sound change in the history of English is dated on the basis of 1, 2, 3, 4 spellings, one of which it turns out doesn't actually exist, One is from 4 centuries after the mooted date of the change, so you're left with 2 spellings from one manuscript to date, something that happened across the whole of England. And that tiny data is, I would say, typical of philological argumentation. So I was already starting to think in bigger data terms, and then I came across this quotation, which really resonated with me. All philological inquiry, whether classical or otherwise, is now a special case of corpus linguistics, and for this audience, I crossed out corpus linguistics and wrote text analytics. So I'm going to explain a little bit more about philological inquiry, a little bit more about the corpora we use, and then I'm going to show you some new things I've been doing. So philology, if you've not come across the term before, has been variously defined: the scholarship of textualities, the discipline of making sense of texts, the forgotten origins of the modern humanities. But essentially, it's about written text and how written text works, particularly historical written text. And I think we're now at a rather special point because of technological advance, where computer vision, manuscript digitization, and digital font design have coalesced, where we can actually do some things that would have been totally impossible a few years ago, and that will radically change the field. We're already quite blessed with corpora for the period I work on. We were talking at dinner about the absence of corpora for African languages. We're very blessed by contrast. We have the Dictionary of Old English corpus, which has been around since the 1970s when it originated on punch cards, which has 3,000 or more texts, 3 million plus words, and claims to have at least one copy of every surviving Old English text. But there's quite a lot of loss still. So here are some of the things we lose highlighted when you compare to a manuscript. So different letter forms, word division, punctuation, are not represented as they occur in the manuscripts in that corpus, and nor are variant texts. So when a particular work survives in multiple manuscripts, we only have one text of that work, and so variant readings, different spellings, more evidence for the Old English language is lost. And I've been doing the pilot work over the last 2 years with Ellie to build a new corpus of Old English, and this is the big project that I have to write up as an ERC in the coming year. And the aim is to build a new corpus that encompasses all texts in Latin, French, and English from all manuscripts containing any English comprised between 600 and 1225. So that's about 19.5 million words from 1,000 manuscripts across 14 European jurisdictions that will record those manuscripts in a new level of detail, be the most detailed corpus of early medieval English ever assembled, the first corpus of Latin texts from England, the first palaeographical corpus of any language I'm aware of, and offer evidence for a host of writing practices that we don't really yet have evidence for, like word spacing, line end hyphenation, punctuation, and so on. Today, I'm going to talk a little bit about the building of that corpus, and then I'm going to tell you about my problems, of which I have many, in the hope that you, all being very bright computer scientists, will help suggest some solutions. So the basic technology that enables this is HDR, a branch of computer vision. I probably don't need to explain computer vision to you. We're working within the platform Transcribus. This has some limitations, but for the moment it's probably the best available. And we trained a pilot model on the basis of 24 manuscripts and 800 pages of Old English, ranging in date from the late 9th to the end of the 12th century, with great labour that nearly killed a few of them from some research assistants who checked things. So the corpus had to, the model has to cope with script as diverse as this, starting in the late 9th century and running to the end of the 12th. And we achieved 96% accuracy, which is within the benchmark range for high-performing HDR models, which means that it can do things like this. So this is a page of a manuscript it's seen, but not a page that it's seen from that manuscript. And so this is the inference from the model. It's a page of the Exeter book, for those of you who are philologists. And that's what you get, a few clicks of a button. And it's very good if you actually look at it. So you can see it recognizes the macron and thon. It gets 3 different shapes of Y in red. It gets high E ligatures in orange. The only place it really struggles is with lesser common characters. So there's a Z boxed in blue there, and there's very few Zs in Old English. The model hasn't seen many, and it guesses a G. So it's very good, essentially. And this enables us to start doing all sorts of exciting things. So, for instance, we can draw graphs that show the history of different letter forms over time. So Old English manuscripts use 5 different shapes of Y, which are represented here, and you can see that early on, in the 10th century, scribes use a variety, but then by around 1000, one form has become predominant. So there's been a kind of standardization process probably behind that. Another feature of Y is that it sometimes has a dot and sometimes doesn't have a dot. We can see from this that in the late 9th and 10th century, undotted forms are the norm. By the 11th century, dotting is the norm. So you're seeing changes in writing practice in this data which have really been invisible to this point. You can also plot scribes on graphs on the basis of very rich scribal profiles. So this is a PCA of training data looking at the relative frequencies of each letter form they use. And what we've color-coded the manuscripts by date here, so that green is 10th century, red to orange is 11th century, and blue is 12th century. And what you can see is that they actually kind of organize in the chronological order that we've been told they should, which is quite neat. So you have the 10th century at the top, then the 11th century, and then the 12th century below. And down in the bottom corner, you have Hatton 20, which is the earliest manuscript in the training data, and an absolutely glorious outlier in every experiment we've done. I promised problems, and I have them. So some of these problems are to do with computer vision, some of them are to do with text analytics, some of them are to do with other things. So one problem we have is that we know that the manuscripts that we're going to run this model over will contain letter forms that the model hasn't seen. And we need a way of identifying those unseen letter forms. We've tried a few things. So one thing is to look at the confidence scores assigned by the model for different predictions, but that seems to essentially correspond to manuscript damage. So these are the top 15 least confident predictions, and most of them are in that line at the bottom, whereas you can see there's bleed through from the other side of the page. So it's a good way of finding places that a human should probably look at, but it's not a good way of finding the kind of unrepresented characters that we've talked about. Another possibility is looking at these confidence bars for all of the predictions in a particular text, and potentially the ones with the biggest bars are the ones that could have further scrutiny in case there's a distinctive letter form there. Another computer vision problem is to do with how visually complex and how many layers many surviving manuscripts contain. So we can see here that there's been various levels of annotation, and so that we need more advanced methods of layout analysis that can either ignore or pull out the glosses. We need to be able to perhaps identify where there's been correction automatically, and we also need to be able to align glosses and lemmas so that where the scribe has written affirmazione in the left-hand margin there, we need some way to connect that to the right word in the main text. And we could do that manually, but when you've got a corpus that big, you don't want to be doing too much manually. We also need to think about correction and whether there are algorithmic possibilities of correction. So if Mike fancies moving on from OCR to HTR, we could do with some help. So we've estimated that to correct a kind of even smaller version of this corpus would take 7 work years of 45 weeks. So correction is slow. And then there's a methodological question of whether we should actually correct at all, or whether, maybe not whether we should correct, but whether it's economically feasible to correct, and whether actually the 96% output is actually okay. There's been some experiments in stylometry with degraded data that show you don't necessarily need perfect data to get good results. We also would like to lemmatize and tag the corpus in various ways. I had some ideas for this, and then LLMs came along, and those old ideas are not necessarily the best ones anymore, because actually ChatGPT, with very basic prompting and the public version, gives you extremely good tagging for Old English, just out of the box. It's less good with more dialectal Old English and less good with late Old English, but for standard Old English it's very good. Where it's less good is semantic tagging, where it's quite imprecise and also hallucinates some tags that are not in the tag set. But clearly LLMs will have a role somehow in doing this economically, I think. The problem I've been wrestling with most recently is how do we actually analyze so much data? And now I'm conscious that for you this is not big data, but for philologists it definitely is big data. So this was something I gave a conference paper on last week, which is 50,000 forms of S from 30 manuscripts. So the basic data is like this. You have a folio, you have a line number, you have the form that contains the S, you have the shape of the S, you have the position in the word of that S, the character preceding it and the character following it. And the task is to find what patterns there are in this. So we were essentially coming up with whatever we could from scratch, mostly on the plane. And so here's some examples. So one of the claims is in the literature is that long S is rare at the end of the words. So this shows the main forms of S by the position in the word. Then the second table is comparing the actual distribution of these S's compared to an absolutely even unweighted distribution. And then the final one computes that relative to the number of instances of that S. So it's a kind of factor weight. And so we see it is true that long S is rare at the end of the word because you've got a negative factor weight there for long S in final position, but it's actually not the strongest effect in the data, which is actually for medial round S. So paleographers were right, but they missed something that was actually more prominent. We've also started to try and look at how multiple collaborating scribes look in the data and how scribes' work evolves over their stints. So this is all of the folios in one manuscript of the Old English Gospels. It's believed that each Gospel was copied by a different scribe. The Gospels are color-coded so that you can see that Matthew and Mark are relatively homogeneous, but Luke and John are more diverse. But there seems to be a strong focusing tendency. So even the scribes of Luke and John are kind of focusing towards Matthew and Mark's norms for the use of S, at least. This is clearly just one letter, but it's an interesting pattern. I really like the shape of that. So the data analysis challenges, as I see them, the data is big and big enough that it's difficult to stay philologically grounded. The data is very multivariate. So manuscripts, texts, and even individual pages are copied by multiple scribes and sometimes by multiple different scribes. I've only been looking at S, but different scribes use multiple different letters and forms of those letters. And the manuscripts, texts, and pages were written at different places and different times. So those are all big challenges. Moreover, the number of texts that we have that are securely dated and localized are very rare and often quite short. There's much more data from some periods and places than others, so this is a graph I recently drew, and I had no idea that there was such a spike around 1000 in the production of English. It dominates all other periods for English. The traditional datings and localizations cannot necessarily be relied upon, so we need to maintain a distance from received wisdom in the analysis, and we also need to try and account somehow for survival. So what we have is perhaps only about 7% by one estimate of what once existed, and we don't know how representative that survival is. So a final thought, that in philology what's usually mastered is the occasional forms, the really unusual ones, that when a scribe kind of falls asleep and accidentally writes the thing he really wanted to write all along, but the teacher had told him not to. It's the aberrations. In machine learning, by contrast, it's the regularities that a model tries to learn, and when you task it with inference, it predicts. So in that sense, are philology and machine learning actually incompatible? Because machine learning runs the risk of effacing those occasional forms that you're actually interested in. That's it.
Thank you very much for your talk. Do you have any questions?
Thank you very much, Mark. I have a comment on the compatibility of machine learning and philology. And essentially, machine learning is, so then as far as I'm concerned, is equally interested in rare phenomena. Sometimes, and there are essentially two approaches there. So to disregard them, because they are outliers, or to investigate them and to understand what they actually contribute. So in this respect, there is quite a lot of research, for example, on out-of-domain distributions and on the the word just came out, the precise term, on the certainty of predictions, right? So and then in your case it will be quite interesting actually to see. So then if you have greater uncertainty, and then you indicated the simple way of measuring uncertainty by the probability, right? But then there are many other approaches to measuring uncertainty, and in this respect, so then again, so probably this is a question to Elizabeth measures. She actually wanted to experiment. Do you have any comment on this?
Thank you very much, and I will probably be asking over lunch for a short reading list on this topic because that's really interesting. To this point, we've really just taken the out-of-the-box probabilities that Transcribers gives us. We haven't experimented further, but we would love to. Yeah, thank you.
Yeah, we'll have another question over there.
Thank you. So about the character recognition, two ideas. One, why not take all the forms that you have recognized, for a particular letter, so a particular glyph, that is, and then doing an analysis on which of the forms are most different, like outliers, but only within the same identified glyph. And one technique, but that's really from the top of my head, that could be interesting, is like when you have those diffusion models that often are used for image generation, like you could do things like which parts of the image contribute most to its identification as that specific glyph, and then remove all the rest, or see how much there is of, black ink that does not contribute to the identification of that as that glyph. So that could lead potentially to discovery of those new glyphs that are recognized as something else than they should be. Very kind of, yeah.
And that's a very helpful suggestion too. And we didn't do it, but a collaborator found a way to pull all of the instances of a given letter that we had labeled as a particular way out, and then I can certainly see there are other approaches in the field where you compare those, as you say, and look at the outliers. There's maybe an underlying challenge with character level segmentation in HTR, which it's more word level typically, and actually segmenting the individual characters can be a bit problematic. But
yeah, I think that's exactly with the diffusion. You could kind of try to mask everything that the model does not think is that letter actually. Something like that. So then you separate those parts, and then you do the comparison, and what are the outliers then?
There's a technique, the Gaussian elimination techniques, where you would take them and you would undo them at each stage, and you'll be able to see the result and the noise, how the noise is introduced. So then it's being able to evaluate those at individual stages. So exactly that technique, like I said, what you explained, is a full pipeline that you can work with, which we've done on fingerprints.
Oh, wonderful. Thank you.
Yeah, just a quick question. So you've been using Transcribus for the transcription side. Have you done any tests to compare its performance with just providing something like ChatGPT with the images? Because there are rumours going
I haven't done it recently, but whenever I have done it in the last 3-6 months, the results are very poor. I mean, I think handwritten is maybe one thing, and then print is maybe another. But the bigger question is actually about Transcribus versus eScriptorium and the different business models of those two companies for us.
If I might just add something to this,
Yes,
just very shortly. I think that's that. I think we talked about this. There's this kernel study, I think, which did these comparisons, and they say that always the best result is Transcribus followed by cleaning up.
Okay, so then a couple of hours later, so then we can finally we finally managed to fight the machine, and actually I am going to talk about how to fight, so then how to use language in order to fight in various contexts, right? So then specifically, how to use large language models in the context of democracy. And this is the topic of our ongoing project funded by Horizon Europe. So the title is iDem, so which means intelligent democracy. And then before I start, actually, I want to show this picture. So first of all, we are in Spain. And then this picture by Goya from the 18th century, it looks not out of place in the expressionist movement of the 20th century. But then the reason why I'm showing you this is because quite often when people talk about politics, they have the metaphor of mad fight, right? The typical example, the most recent example, is what happened in the American elections last year, but then practically any elections, and probably in the local context, you can also resonate that people don't trust politicians and they think that they fight. And this actually defeats the purpose, defeats the basic purpose of democracy. So that the idea behind democracy is that you have politicians who listen, and then to listen to the voices of the people, and they are elected as representatives, and essentially, so in this case, we delegate responsibilities for running the country or running the specific decisions on the local levels down to the elected politicians, and now we don't trust them. And this is a problem, and one of the answers to this problem is called deliberative democracy, in the sense that the stakeholders are directly involved in deliberation, hence the word deliberative, and also in the final decision making, so their voice is heard. This is a great goal, and this is the reason we have a project, and also this is the reason why the European Commission recently established their Center on Participatory and Deliberative Democracy with the aim of promoting the best practice. So the context of the context of deliberative democracy is actually based also on political theory, and this is where I told you that that the word language, it sometimes appears in the context of political debates, but then if you look closely at how philosophers and politicians talk, they refer to language all the times. So one example is, we have one of the political philosophers who is specifically responsible for the modern take on deliberative democracy, Jürgen Habermas, and his actually reference is to the ideal speech situation, right? And the word speech, it actually speaks of language. Right? So, and it includes several conditions. One of them is freedom of expression, and then the word expression means that, right, somehow expressing themselves in language. Obviously, he didn't actually talk much about language himself, but the idea is that, okay, so you have free participation and the freedom of expression. The other example where, so the other condition for the ideal speech situation where language becomes important is that the focus is on argument, and argument obviously is expressed in a language. And one of the examples he actually provided for improving the quality of argumentation is what he calls reverse argumentation. You have two groups, Group A and Group B, and when they debate, Group A needs to start by presenting the argument, by summarizing in their own words the argument of the group B first and then vice versa, and this gives the basis for reasonable argumentation which aims at reaching consensus, right? And then the final thing again, so this is in his words, this is primarily about power. So you have a doctor, an expert, and you have an elderly person in a hospital, and then in a sense there is an imbalance in power here, quite visible. But so this is what is important for Habermas. For me, it's important that they also have different capacity to use language in order to argue about certain choices, right? And this, starting from now on, I will switch first to language in general and then to large language models. So first, language in general. So this is the view coming from Halliday's systemic functional grammar on what actually, why society uses language, what language does in a society. So then this is well before the rise of ChatGPT, but the basic idea is applicable to ChatGPT. So in our case, if you want to talk, you have the communicative intention, and you need to realize this communicative intention in the form of a text. And then there are various ways of doing this, and once you have, how do you do this? This realization happens by, Halliday's term is instantiation. You instantiate the resources available in the system of language, and then the end result is a text. The important thing is that by writing more texts on a certain topic, you actually maintain some kind of cohesion in society. And again, yesterday with Mike, we chatted about cumulative culture. So then culture needs to be sustained, and the only way it is sustained by means of language. So if you have generations of birds, they just don't know what happened in the previous generation, right? So then apart from the genetic drift, okay, this is all good. And so in the case of, then what's the place of language models? Essentially what they do, they learn language, then they have millions of examples of language as a text, and they produce lots of examples, they produce a good representation of language as a system, and this representation also covers a range of different registers, and registers quite often reflect to some degree the individual cultural domains, right? So then this is a great tool which learned language roughly in the same way as we did, except that, so then if we talk about language and you talk about communicative intentions, I have intentions, right? I want to talk something to you, right? Take ChatGPT, you can ask ChatGPT to write my talk, but then you can't actually, so then ChatGPT doesn't have intentions of its own. Then language models are different in this respect, right? So then they don't speak about what is going on. And then, the task for a language model is essentially just to predict the next word. The databases are not comparable to humans, because I estimated that it takes about 56,000 years for every one of us to read the amount of texts consumed by ChatGPT, and obviously by doing this, it consumed lots of different genres and lots of different kinds of texts, and then this is not a match to us. So the other interesting thing is that again the estimates vary, but most of the time systems of this kind, they are trained primarily on English. You take about out of the 500 billion words, and that's only for GPT-3. So there was an increase in the number of texts submitted to later versions, to more modern versions of the tools. So but you take about 500 billion words, 90% of them are English. The rest covers, again, estimates vary, but around 100 languages, right, including Old English. So probably far fewer words. It's good that the system of language can be approximated. So then the system of English in general can be approximated. What is more, systems of other languages can be also approximated because there is such a good approximation of the system of English. And this means that the systems are quite good in terms of predicting what is next. What is also good is that they also know quite a lot about human society, because you have examples of language which reflect the individual cultural domains, right? So then this is all brilliant. There is a kind of a question about multilinguality, in the sense that that multilinguality is there. You can ask the system to translate from Old English into Modern English, from English into Chinese, and vice versa. But then this is primarily so that because 90% of this is based on English culture. Therefore, the likelihood of producing texts in so that the producing culturally appropriate text in less dominant cultures is actually less. And then the other thing is that the output, so then how they're different from us, is that you read outputs. And then I think that, Ondřej, you mentioned that you also teach students to interact with ChatGPT as if it is a friend, right? So then that's right, but then, in the case of your students and in the case of ourselves, the intention is there. In the case of ChatGPT, the intention is not there. And there is a famous example when Bing Chat was interviewed by a New York Times journalist, and then it expressed falling in love with the journalist, right? And the journalist spent the rest of the interview trying to convince the model that it doesn't work. But then obviously, because you read the output, so if someone tells you that he or she loves you, so then obviously you need to respond in one way or the other. Right. So then this is kind of the preliminary. So my take on what large language models do with language, and then getting back to the to what extent we have problems with the semiotics of participation. So and this is again. So then we talked about variation quite a lot. Today, so in my case, the focus is on variation within the same language. So then you have one and the same language. So in this case, let it be English. And then you have different users and different conditions for language use. For the users, obviously you have age, dialect, or education level. And we are all different in this respect. And there is clearly a difference in how people express themselves or have the ability to express themselves. Then the other thing is that if you have cultural domains, those different cultural domains, they are reflected in different sub-varieties of language. So then in functional tradition, they're called registers. So you have academic register, you have the register for talking to children, or you have the register of political argumentation. And in a sense, one and the same person needs to be involved in all of them, right? We have a young student, and we want to introduce this person to the academic register, and that this student might have children, and then is able to talk to children, etc. Right? So. And then there is also variation in terms of politeness. So in general, communication styles. So communication styles are different, and so then the politeness or so in different cultural domains, you have different expectations on the communication styles. Okay, and then this all. So then if you look at this, languages differ. So then and with different varieties of language differ. Different users, they also differ, and this naturally creates in and out groups, right? So then those who are who know the kind of language which is used by so that then in this register, and also this is a marker of identity, right? So that I belong to this group. I am so then a representative of this academic community, and I can present a talk on a specific topic. Right. So in this case, but then, and this demarcates us from them, right? So then language is actually quite good in creating this separation, and then but then if you have other people who are not capable of doing this, then you have language barriers, and because of this, there is a lot of debate on to what extent language needs to be inclusive here, and so there are some advantages for the prestigious varieties of language. Why do we teach our students to write in proper academic, so then in my case, proper academic English, proper academic Spanish, is because, so that then one example is terminology. If they use consistent terminology, if they use terms in the right way, they are going to be understood better. So terms can be turned into abbreviations. So there is a reason why In science, we maintain terminology. In political argumentation, again, look at the outputs of your city council, and you will see lots of very specific terminology coming out of them. And then again, they aim at consistency, but then again, linguistically, there is a problem with terminology, and this is again. So this is what I like. So this example from Halliday and Matheson I like very much. So you have a sentence, and this is a natural sentence. How fast cracks grow in glass. So in this case, you have some. So that you have the predicate grow, and then something grows, and then you know where it grows in glass. So everything is transparent here. So syntactically, so by knowing a little bit of English grammar, you can see what is going on, right, with cracks. But that's not a term. And when so then it's assuming that we are in the field of physics, and we tell students to write in the proper term. And the proper term is glass crack growth rate, right? And then so that it reflects actually how fast cracks grow in glass. And then from the viewpoint of the structure, so then before we had a very, very explicit syntactic way of linking cracks and grow. They are next to each other again here in this, so that in this term, but then this is a rate, and then you have growth rate, and then you have crack growth rate, and you have glass crack growth rate, right? So all these things, they are actually not transparent here. So, and then this is not the only, so then in this particular term, it's actually easy because you read it backwards from rate to glass. Right? Then you have a different term, search engine optimization services. Then in this case you have engine, then you have search engine, then you have search engine optimization, and then finally search engine optimization services. And also the word services, so when you create terms, you tend to create terms which are quite generic. So what services, right? So then these are some tools which are used for certain purposes. And then you have maternal services user representative. And then in this case, the structure of the term is completely different because this is maternal services. So then maternal services users, and then finally you have the representatives, right? So, and then these are not the same services as in the search engine optimization services. Okay, so and then this is about inaccessibility of terminology as coming from the democratic institutions. So at least as far as this project goes. This is about democratic institutions, so they produce inaccessible bureaucratic texts. And we are guilty of producing inaccessible academic English as well. But then there is also the opposite problem. You have the users of those city council or other democratic services, and then they so the input which doesn't conform to the regulations is rejected, right? So then this inaccessibility works on two ways. And then the answer in our case is to use large language models. So this is actually an example, and this specific example is coming from a leaflet produced by the European Commission. So it's a multilingual leaflet which outlines the basic principles behind the end-of-life regulations, right? And then they have a term, and quite reasonably. So I'm not sure that many of you have heard the term unreasonable obstinacy before, and they also expected that probably the patients facing their end-of-life scenario, they also don't know the term, and so because of this, the term is explained, right? But then the way it is explained in precisely the same way, so then as I talked before. So then in terms of dense, actually fairly dense bureaucratic language, which, so then imagine someone who is approaching the end of life, it's quite difficult to understand. So the aim of this, this project is to, when you have explanations of this kind, you need to unpack them. And unpacking goes like doctors and nurses. Actually, there's no mention of doctors and nurses here. They are implicit. And then if you can actually extract what is there and make this more explicit, then this is one of the tasks of the project, right? So, and this is essentially the aim of the project. So we are currently we are in the second year running for this project. So essentially, because participation for the outgroups is limited, we want to find a way to improve the possibility for their participation. So, and specifically we focus on three groups: people with cognitive disabilities, migrants, and the elderly. people, and then we have also have 4 languages in the project: Catalan, Italian, English, and Spanish, right? So and then out of initial research in terms of developing classifiers for what is difficult, we essentially estimate that if you take institutional texts, then depending on the language, depending on the source, but most of the sentences, so this is on the sentence level, right? So then something like above 90% sentences are considered to be difficult. They're difficult to understand. And then the basic idea that you develop a range of language models in order to simplify and explain less accessible language, right? And then in the opposite direction, so in the institutional norms, we can reflect those norms in a generation interface, and then this leads in the end to what Jürgen Habermas called the ideal speech situation, in which you can achieve at least linguistic equality. So not necessarily the equality in freedom of expression or the rational argumentation, but at least some aspects of equality can be achieved. So these are some of the things which are doing. So for example, if you have a text, then if you have a sentence in this text, then one of the tasks is to predict whether the text is complex or needs a simplification or not. But the other task is also to predict what kind of simplification is needed in this case, right? So and then essentially the typology here, it follows the idea of of either on one end you need to delete stuff, right? Because it's probably not relevant, and you probably don't need to. You need to avoid overloading the target user with complex text of this kind. And then, for example, this is the first sentence from Wikipedia from the current British Prime Minister, and obviously the only thing which is needed there for most of the purposes is the name of the person, right? Or you go down, and then you go down to something like explanation. So when you have an unreasonable obstinacy, and then it needs to be explained, right? So this is the other thing which is quite important for us is interpretability. So it's so easy to have a large language model. It makes prediction, so it makes either a prediction or it makes it produces a simplification. And what we actually would like to know is why this prediction is made, why simplification is made. And for this task, we use the integrated gradients. It looks like then it's actually then I can see the lines there, but probably it's a bit difficult for you to see them. Just a kind of an example. So we have a sentence, and the sentence claims that in 2018-20 life expectancy at birth in Scotland was 76.8% for males and 81.0 for females, right? And so then essentially what needs to be first of all, the sentence is complicated, and what needs to be simplified in this sentence, the model looks at what contributed to predicting the need for an explanation here, and the explanation is required for the word life expectancy. In addition to this, the word the very specific range of ages is probably can be simplified here, and then also the range of years in 2018-20, right? So then this probably needs to be simplified into from 2018 to 2020. Okay. And then the other thing is that also, in addition to so in the opposite direction, and this is our ongoing research. So effectively, if you have someone with lived experience, someone who then a patient in the hospital, or a person with cognitive disabilities who wants to contribute their point of view on how mental health services need to be organized, then they tend to talk in terms of storytelling. So this is what happened, right? But then what is expected so then in a deliberate situation, and what is expected by the institutions which need to respond to such views, they need to have arguments. And then in this respect, one of the translation engines that we are experimenting with is translating stories into arguments, so whenever possible, and also with with the aim of making them institutionally legible, right? So in the ideal case, we can get better representation for the disadvantaged groups in deliberative contexts, right? Okay, so now I am ready to conclude. So essentially, so what I wanted to tell you is something I didn't realize when I started the project, is that language by itself, it actually is a tool for communication, but also this is a tool for social stratification. And if you want to include the outgroups into the process, then LLMs ideally provide useful tools. At the same time, they are also vectors of bias. So then this is a topic for another talk. So then we need. So I would like to talk about this as well. And then so there is a kind of a question about diversity in terms of registers and user preferences. And then ideally in a project of this kind, you need to address the variety of views, right? And then we have a number of case studies with a number of organizations. So then what I like is the fact that the Barcelona City Council is one of the partners in the project, and we aim at improving at least over there some of the texts. But then the last line is actually roughly in so then it's about something else, right? It's about then generalizing. So this is a presentation on the specific project on large language models. The question is, what is coming next? And I think that it was asked today about a number of today and yesterday about different speakers, and then my actually take is that we don't know the future. And I will conclude with 3 pictures. So this is how the car was designed in the first instance, right? One of the first examples of a car, you have a carriage, and then suddenly you have the possibility of riding this carriage without the horse, right? So you take out the horse and you have the carriage. And then, so something within something like 10 years, cars of this kind appeared, right? So then with the engine in the most logical place, and then with the passengers at the back after that. And now we are in the age of electric cars and in the age of driverless cars. Now, so then what to do with this? So then the engine is, so the space for this engine is no longer needed. The driving wheel is no longer needed. So then how do we design the car of the future? So in exactly the same way, what is going to happen in society with the rise of language models, which essentially they don't change the need for communication, but they change the opportunities for communication, and then how society is going to be reorganized around this. Frankly, I don't know, but I would like to see. So I would like to live to see how the changes happen in society. Right. Okay. So thank you.
Thank you very much. Okay, thank you so much. Are there any questions?
Already?
I know we need the microphone for this, so Ondřej, go ahead. So one thing with the microphone, as you probably realize by now, it makes a lot of noise. So just try to just not put it so close to your mouth and not move hands around and stuff, because it makes like tremendous noise. Sorry about it. I'm so sorry. You're looking at me like puzzled, but just trying to avoid so much noise as before, because we have before the speaker. So let's see if we can just keep it still.
I had a theory that it was when people with smart watches are holding on. I'm slightly sussing watch, but it's not true. That's not correct.
Because now it's like working perfectly. It's not making any noise at all. So you just go ahead. Sorry, Ondřej.
try only moving my mouth,
Okay.
but not too much.
I thought it was beards as well that was.
Shave the beard.
When I was sitting at the back yesterday and he was making that, I thought, are you doing this?
No, it was at this distance. Okay, so anyway. Yes,
So northern dialect with very closed vowels.
all right.
How does it compare when you're looking at the language complexity? How does that compare to some of the measures that are now used? You know, either very simple ones like the ratios, the lexical complexity, or the, was it Kolmogorov complexity that is often used, or those that are used for school production?
So the answer is that the traditional measures, they all appeared around the 1950s with the aim of reflecting the complexity of a text. So then typical examples are flash Kincaid or fog or yes. So then measures of this kind, they had their place in the 1950s because there was an easy way of by counting the number of syllables or by counting the length of words to make a prediction. The thing is that so then we have an ongoing paper, so that it has not been published. So but I will send you a paper once it is out. So essentially, first of all, they tend to work quite. So that there is correlation between more elaborate measures and these measures on the corpus level. So if you have 20 documents, each of them 1,000 words each, then by aggregating statistics from such simple measures, you can get what is difficult. If you want to look at the sentence level, then practically they don't correlate well with with human judgments, and our models correlate with human judgments better. So in this respect, if you have better models, obviously they have more parameters. They take into account not the fact that the word television, for example, is relatively long, and it contributes quite strongly to the difficulty of the text, according to all the measures such as a flash Kincaid or fog or smog. But then probably it is quite easy, right? So then models which are essentially based on pre-trained language models, such as BERT. So then we use pre-trained language models for the prediction, and large language models such as Llama for the simplification, or for text generation, right? So then they reflect much better what is complex in a text.
Thank you very much.
I've just got
That's why it didn't make any sense.
Yes, I did. But
Which might be good news.
in a small room of this kind, we can probably talk.
So just, it's a question about, so way back, Seal did the speech act, theory. So he talked about, he talked a lot about sincerity conditions and essential conditions. So where do you see, two parts of this question. How do you think speech act and communications has changed? And do you think those conditions still stand? Because at the end of the day, the effect of a conversation has become so variable now. You know, when we look at the illocutionary force you showed us, in terms of trying to achieve meaning, but the effect is varied. How do you see that having changed from those original ideas, and does Seal's view still stand?
Okay, so in my view, what specifically John Searle was doing is not very different. Is very much in line with the functional tradition, right? Yeah. So there is no question about this. At the same time, I think that what is coming from him is essentially a relatively superficial assessment of how language is actually used in society. So then we can take some of the conditions he talked about, and then we can put them into the model. But so at least in this model, the focus is on the linguistic realization, right? And on how language is actually used, not in the, again, so he mostly talked about, very much like Habermas, about the ideal speech situation, right? And then we are dealing with actual texts coming from the democratic institutions, city councils and the like, and then we are detecting what is actually difficult for individual groups of population, and to what extent the texts can be modified by means of large language models. So in this respect, so I don't think that society, so then okay, very much in line with my, so okay, so contradicting my last slide, that society is going to change very much like cars are going to change. In a sense, so what didn't change, by the way, is, so then over the years, since the 19th century, is the size of humans. They need to get into the car, right? And if you look into the carriage, into the size of what is needed for the carriage, if you look into this Rolls-Royce from 1907, and if you look into this modern car from 2025, they all are of roughly the same size, because we are all the same, right? The communicative needs, the intentions we have, they are likely to be a bit more flexible. So it's quite likely that they changed a little bit, right? So that again, so if you look into the 15th century, and then this is in line with some of the chronological studies, diachronic studies we actually discussed earlier. So then the register of academic English didn't exist, right? So then the aims of academic communication, they were very different at the time. And then there were studies on the basis of the Transactions of the Royal Society, a journal which exists from the 17th century. So then reflecting how much language changed from the from the start of what appeared there and until now, right? And how the register of academic English developed. So in this respect, yes, there are changes. However, I don't think society changed that much. And then whether the use of large language models is going to have an impact, let's see. So definitely it is having much greater impact than just the arrival of computers by themselves. Because the computers by themselves, they helped with typesetting, right, or sending emails. They didn't change the nature of communication. With large language models, the nature of communication is going to change, and I don't know in which direction and what is going to happen next. No, I don't have the crystal ball.
I mean, more than cars, I mean, an analogy that's often used is electricity. This very generalized technology that just influences everything, and it leads to the development of services and business models, but also ways of societal behavior that we just can't predict, and nobody could predict it with electricity, that it would have that impact.
There is a great example in the 18th century. There was the full moon society in this country. So, okay, in that country, in the UK, right? So then the full moon society, right? And the reason why it existed as the full moon society, because they had their debating sessions during the full moon time.
That's different to what I thought it could be.
Right. No. And then so that they can actually leave the debating halls when it was at least some light on the streets. Exactly. Right. So then obviously the arrival of electricity changed all that, and then we actually spent. So again, I wonder how life existed in Spain before the invention of electricity. So you couldn't have a dinner after sunset, right? So then how?
Well, there were candles probably.
Sorry?
There were candles probably.
But so we
could still have dinner at 10.
Right, okay. So next time we can try having our lunch, so our dinner with the
A
candles.
historical take on dinners.
You could not have caught an electrified train, high-speed train, from one end of the country to another.
That's for sure.
Okay, thank you very much. Let's thank our speaker again. Thank you.
So let's start. I intend to discard some slides, okay, in order to shorten the presentation, and you'd appreciate it. Okay, so so the purpose of this talk is to show how to effectively design and develop an artificial intelligence-based assistant for linguists to do critical discourse analysis. Okay, as simple as that. And to evaluate this system, we experimented with a very small corpus, because it's a qualitative analysis, not a quantitative one, about affective polarization in the Brexit debate. Okay. So what is affective polarization? Well, I chose this topic because it is part of the project, of course, but also because it has been a growing phenomenon in recent years. Okay, affective polarization is about groups in conflict, groups in where there's an in-group, okay, in which there's a positive sentiment towards one's own group. Always, we are the best ones. Okay, this is the in-group, and the out-groups, where there is a negative sentiment and negative emotions towards those who identify with opposing ideas. It is as simple as that. They are the worst even ones, and we are the best ones. And this is affective polarization. And it happens in political debates, but also not necessarily in politics, but in social debates, okay? Perfect. So, this is the ground, and it's in social psychology. I'm going to reduce my presentations because of the reason that I explained before. Okay, so, I chose just a very small corpus to demonstrate how well it worked. I chose 631 comments from a video, from a YouTube video published by The Guardian 3 days before the Brexit. The Brexit referendum, I mean the European Union referendum, but popularly known as the Brexit referendum. Okay, perfect. And this is the research question. So, is it possible to use a large language model to examine affective polarization in social media comments? Okay, within the framework of critical discourse analysis, something that could be useful for linguists. It's not to replace linguists' work, it is to assist them, to help them to do a better work, okay? Perfect. Okay, and to answer these questions, we had two objectives. We had to devise a methodological framework, a sound methodological framework for doing critical discourse analysis with a large language model, and we had to devise a proof of concept. We've got to demonstrate that, okay? With such a methodology. Okay, so we use an open source large language model, Mr. Limo, trained with 12 billion parameters, where you know that it supports multiple languages. This is one of the reasons that we chose it, English and Spanish. It has a free API service, which has very good flexible conditions for researchers, as you can see, okay? And these were the parameters and the settings used. But apart from the large language model, we used the methodology of critical discourse analysis. As you know, well, this is a field in which it's sometimes an umbrella term, which includes a variety of methods and theories that all of them deal with the study of social issues through the text. This is the main idea, okay? This is the common denominator, okay? And in this particular case, I integrated Faulkner's discourse analysis model, which consists of three main steps: description, interpretation, and explanation of social phenomena. And I integrated this model into Moulet's critical discourse analysis framework, which focuses on three main levels of analysis: background, thematic, and linguistic. So this is the basis of our methodological framework. As you can see, it is grounded on linguistics theories in critical discourse analysis. Okay? And this is the pipeline. This is the pipeline that illustrates the large language model-driven critical discourse analysis. Okay? how this pipeline consisting of 10 tasks guided the process. Okay, so as you can see, we have background analysis, thematic analysis, linguistic analysis, description, interpretation, and explanation. And well, Mistral Nemo, the large language model, was the engine, okay, that generated all the information, all the interpretations, all the explanations, practically everything. Okay, so, well, but this pipeline has been computationally implemented into a module that has been integrated in TextMeLab, an application, a free access application that is usually, well, the target users of this application is usually users, okay? And these users can do text mining experiments. So from now on, they, apart from traditional text mining experiments, from now on, they can help these linguists to do some critical discourse analysis. Okay, as you can see, this is the interface, very easy for linguists, okay? It is just to enter the upload the corpus, enter the description, a brief description of the corpus, the domain, the location, and then you choose, I want to conduct a background analysis, a thematic analysis, and well, we have some linguistic features on which we're going to focus. In this particular case, for this experiment, we focus just on emotion-oriented lexical markers, just that. But we could have focused on the use of the pronouns, on modality and negation, and there's much more now because we have increased this list of features. Indeed, we have more than 30 linguistic features to analyze, okay? Okay, and well, you have the outputs automatically presented in the application, and the user, apart from accessing all the prompt templates, because these prompt templates can be customized by the researcher, okay? Well, the user can access to all the results in the intermediary steps in the form of CSV files, XML files, plain text for reports. So it's very accessible, that's the idea, okay? Linguists should use it as something to help them, as an assistant, not to replace them. Okay, so what is the first step? Well, the background analysis. So the purpose here is to explore the main aspects in the historical context, political context, social context, I don't know, full context, okay? And this, well, here, as you can see, when you see the Mistral Nemo logo, this means that this information has been generated by the large language model, but not in that way. I have summarized it, because the information is presented in a user-friendly way as a report, as a user-friendly report for the assistant, for the human analyst. But I have summarized because of a problem of space. Okay, so you've got the historical context, you've got the political context, everything has been automatically discovered by the model, the economic context. Each one is a different prompt indeed. We've got more than 12 prompts that are coordinated, and the output of one is used as the input for the next one. Okay, this is the idea, okay? Okay, the social context and so on. So what did we do? Okay, so we examined the descriptions generated by the large language model, and we concluded that factual information was accurate. Perfect. Okay, so no problem at all. But we found two drawbacks. The first drawback, the lack of detailed analysis. Comparatively with information provided by human analysts, these descriptions are shallower in detail. They are accurate and correct, but shallower. There is a lack of depth in detail, okay? So it's very good for human analysts, but it's not enough for them, okay? This is more or less the sensation you have, okay? And the most important, well, I wouldn't say problem, but because we are working out, we are thinking about how to fix this problem, but the main issue for me is that there is a lack of supporting evidence from a scholarly literature. I mean, you've got some interpretations and some explanations, but there's no quotation and no citation extracted by the model from a scholarly literature that could support its own claims, because in that way, this model could be you could find this model as more reliable for the assistant. So what happens? In contrast, researchers, human analysts, have got to cross-check all the information by the large language model by manually comparing the data with external sources. Okay, the ideal situation, why the model could not provide its own citations or quotations from external sources. And we are reducing the time and the effort of analysts. So these are two main drawbacks. Okay, right now, okay? But we are thinking about, and we have some solutions for this, okay? So this is the background analysis. Then we've got a thematic analysis. So in the thematic analysis, the model identifies the most important themes, one primary theme for all the corpus and some secondary themes. Okay, there's much more information than just this. This has been summarized, okay? But they are correct, okay? And then we've got the linguistic analysis. And in the linguistic analysis, we've got different steps. So in the first step, the model, well, not the model, not here. You can see that there is no logo, okay? Because this task was not performed by the model. This task was performed using traditional machine-readable procedures. I mean, the system, not the model, the system identified the most important emotion-oriented lexical markers in the discourse. Not just identify the most important emotion lexical markers, but also the semantic type and the subtype. And we use machine learning, traditional methods, okay, to have this information. Why? Because it is faster and more accurate, as simple as that. We tried to do it with a large language model, but there were some hallucinations in this way, okay? So if it is faster and more accurate, no question, okay? Perfect. But this is a qualitative analysis, so this is the only quantitative part of the analysis. And we didn't use the model for the quantitative part. We were more interested in the qualitative part. So apart from identifying the lexical markers, we interpreted them. And this is the most important thing. So the interpretation of each lexical marker was based on quotations that the model took from the corpus itself. So the model took one lexical marker, then went to the corpus, extracted a comment, and then analyzed the emotional content of the lexical marker with respect to that quotation in order to contextualize the interpretation. And also considering the themes that were discovered in the previous task. Okay, what was the problem? This was performed by the model, as you can see by the logo. What was the problem? There was a type of hallucination, surprisingly. Why? Because we instructed the model to take comments based on one target lexical marker. But sometimes the model took comments where the lexical marker was not there. And in other occasions, the model took some quotations that did not really appear in the corpus. They were artificially created. So this is a kind of hallucination. I mean, things that did not exist, and quotations which are not relevant because it's not there, the lexical marker. So what was the solution? I'm going to present the problems that we had and the solutions that we used to fix them. In some of them, in all the cases, in some other cases partially. Okay, so solution, well, very easy. The solution is straightforward. Forget about the language model. Use regular expressions, morphological information, go there and take the word. Because we already know the inventory of lexical markers. So the question is, try to search it and take the quotation. That's that. So try to take the comments. So very simple, no problem at all. Here, the model had a worse performance than just a very simple way of working. Okay. Yeah. So, we found that some of the quotations were correct. Some of the quotations were correct, but shallow. But this is our great concern. 1/3 of the quotations were either irrelevant to affective polarization or were misinterpreted. So we had the first problem with interpretation of lexical markers just using the model. Okay, what to do? Okay, so this is an irrelevant interpretation for affective polarization. Why? Because as you can read, love your channel from the USA, awesome work you do. Love does not contribute to affective polarization. I mean, most of the works most of the works, most of the lexical markers expressing positive emotions did not reflect in-group animosity from the perspective of affective polarization. Only in that case, this would have been useful and relevant for the study. I mean, most of the cases in which most of the words expressing positive emotions were just for a positive evaluation of the video, a positive evaluation of the interviewer, of the channel. This is not useful for the linguist in this case. Okay, so solution, very simple. Okay, let's conduct a kind of binary classification task. You take the lexical marker, you take the comment, you say relevant, irrelevant, relevant, irrelevant, relevant, irrelevant. We could have done it through traditional machine learning methods, but we tried to do it with the model. Okay, this was the challenge. No problem at all. Successful percent practically in all the occasions. Just a simple binary task classification in which if the lexical marker was tagged as irrelevant, that lexical marker together with the comment was not going to go on the analysis in subsequent steps. It was automatically discarded. Okay? But there was one condition. This worked only with one condition. We've got to instruct the model about what affective polarization is. So the model required a formal definition of affective polarization. Without this formal definition, it didn't work. But if you teach, well, affective polarization is, in groups, out groups, okay, positive sentiment, negative sentiment, we explain it very formally, and it practically, reached, more than 95% of accuracy, so fantastic, no problem at all. So this problem was sorted out. Then we've got the misinterpretations. Well, misinterpretations were more difficult to be fixed out. For example, you see here, I love how all you leave European Union idiots come to a video from a left-wing channel that talks about staying in the European Union just to hate on it. Well, laugh here does not express a positive emotion. Again, it is rather used as a rhetorical device of sarcasm and irony that is used, it is intended to criticize the behavior of pro-Brexit commenters. Okay, so as you can see, initially the interpretation was wrong. This marker is used to express attraction towards the speaker's political stance. This is wrong. Okay, what was the solution in this case and other similar cases? Because the corrective measures were not applied just to single cases, but to groups of problems, okay? Well, so it's very interesting because initially we devised a prompt where we included all the lexical markers in one prompt in a CSV format. Lexical markers, semantic type, and semantic subtype. And then we instructed the model to take one by one and to analyze it, but using one prompt. Then we realized that the same instruction, but not with all the lexical markers, but just with one lexical marker, the explanation and the interpretation was larger, with more detail, and more accurate. So, well, fantastic. So as you can see in the first line, the use of the word laugh in this context is ironic and sarcastic. Have you seen that? Very simple. Prompt engineering. Okay, here we've got another case of misinterpretation, hatred. But hatred, the author expresses that their hatred towards British selfishness it's wrong. I mean, here, the commenter is not expressing hatred. The commenter expresses the perception of hatred in other people. Okay, so this is a very nuanced interpretation that the model did not realize at the very beginning. So what was the solution here? Well, the solution in this case and other cases was, okay, to extend the cotext. So the larger the cotext was, more contextual cues the model had, and then more probabilistic regularities, and the interpretation was finer. Okay. Well, the next one, was to identify patterns of meaning, based on the previous interpretations, and the model identifies 6 patterns of meaning, but the model also explained the patterns of meaning, qualitative analysis. And all the explanations, curiously, okay, but all the explanations focused on the emotional trigger, okay, all of them. So that event or situation or entity that elicit the emotional response on the individual. And we saw that in most of the patterns of meaning, the primary emotional trigger was the potential consequences of Brexit. All this information, I remind it to you, all these informations have been generated by the model. I have just summarized it in a table format. Okay, it was presented in a user-friendly report. Okay, and the last task, let's contextualize everything. Do you remember with a historical, political, social context? So now we've got to contextualize everything. Okay, so we instructed the machine the model in this case, to underscore those aspects in each context that could significantly explain some of the patterns of meaning, or most of the patterns of meaning. And we did it with a historical, so we found many significant historical factors, economical factors, and social factors. Okay, so this final task shed light on the key driving factors that shaped the digital discourse on Brexit. And we saw that these results were in consonance with the information and the conclusions that were obtained in scholarly literature, as you can see here in this slide and in the other slide. Okay, so more or less, okay, it was quite useful, the output, quite useful for linguists, for those people doing critical discourse analysis. Yes, perfect, fantastic, very quick, very fast. Okay, so now, so although large language models have made significant advancements, generative artificial intelligence for qualitative analysis is still in its infancy. Okay, so I have just highlighted the benefits of prompt engineering. So you have some slight prompt variations, and then because you enlarge the code text, or you focus just on a single lexical marker, or you give a formal definition of the phenomenon, the results are much better. Yes, but honestly speaking, there are 2 issues that have room for improvement. Okay, first, the claim should have been underpinned by deeper insights, more detailed information in depth. They are a bit shallower. Okay, perfect. But this is the starting point. The next step is not the future, but the present. And the most important thing for me is that if this should be useful for linguists, we've got to give them the possibility to read, together with the claims elaborated by the model, some citations or quotations from scholarly publications. Okay? Perfect. What are we doing here now? Okay, so we are developing a RAG system. The idea is that the user in TextMeLab uploads the corpus, gives just some metadata descriptions, general descriptions, locations, and so on, and with an annotated corpus by the user, annotated corpus with interpretations and explanations elaborated by human analysts, this corpus is uploaded, automatically converted into a vector database, and then the prompts are enriched with this information. And we are here, we are at this stage of the research. Okay, so thank you very much.
Thank you very much, Carlos. Do we have any quick question before going for lunch? Maybe?
Yeah, at lunchtime, maybe.
Or you are craving for lunch this time? So, I don't know if there are any questions you just don't want to. Okay, so before we go for lunch, can we take a quick picture of all the participants, so you're invited to come to the front of the room, so we may take it, if that's okay to do. Okay.